Hello everyone, welcome back to yet another session by Scalar. Today we are going to look into SQL. So we'll be looking into SQL concepts and also its interview questions. Before we move on and understand what we'll be covering in this session, make sure you're subscribed to Scalar's YouTube channel and also hit the bell icon so that you don't miss our upcoming videos. Also, if you want to learn technologies and frameworks from industry experts for free, we conduct masterclasses. You can check out that link in the description. Now let's look into the topics which will be covered in this session. So to start off with, we'll start off with the very obvious topic, which is what is SQL. We'll be understanding the basics of it. Once we understand that basic, we'll show you how to set up SQL Workbench in your local machine. Because once you set up Workbench, you can start typing in commands and you can start practicing it. Once that is done, we'll move on with SQL commands. To start, we'll be looking into database commands, how to create a database. And then we'll be looking into table commands, creating a table, truncating a table, deleting or dropping a table. And then moving ahead, we'll be showing you how to insert values, how to alter the values, and how to update them as well. And after that, we'll be looking into different clauses like order by clause and where clause. And finally, we'll be looking into one of the most integral and important concepts in SQL, that is joins. Once all of these concepts are done, we'll move on to SQL interview questions. Interview questions are a must. If you're sitting in an interview where they're going to ask you SQL questions, please go through these questions. This will really help you. So now that's basically it. Let's get started with the session.
So to start with the basics of SQL, first we will try to set up the environment in our local machine. And to our implementation part, we are going to use the widely used transactional database, which is MySQL. So first let me show you how you can set up environment related to MySQL in your local machine, be it Windows, MacBook, or any other laptop, desktop you are having. We can simply download it from the MySQL dev, this environment, and we can set it up very easily in just few steps. So what you need to do, you can open the web browser and simply type MySQL Workbench, and after that you can mention your machine name directly if you have Windows or Mac, whatever it is, and simply click here. And after that you will see this link dev.mysql.com. Simply click on this URL and here it will redirect you on that respective machine environment you have, the operating system, and even you can select it directly from here. If you have Windows machine, you can simply toggle onto that option, and here it will provide you this option to download the respective jar files or any kind of libraries which can help you to set up this workbench. So I am using Mac OS, so I'll just click on here and then I will download this .dmg file. I can simply click on it and here it will ask for the login or sign up. No need to do that. Simply click on this no thanks, just start my download option and it will start downloading this package which we can see here. And once this download part is done, it's just all about the double click and that .dmg file will directly install this MySQL Workbench in your system. So here as we can see, we have downloaded this one, and since this MySQL Workbench is already installed in my system, no need to do that again. So I'll directly show you how you need to proceed on the MySQL Workbench, how it looks like and how we can perform different operations. So let me go there. Cool. So after installing the MySQL Workbench, it will look like this. Its environment, or it completely provides you the ID sort of environment where you can write your SQL commands. Also, once you will start setting up MySQL Workbench in the local, it will ask you for root user and password, which you can set up accordingly, because this MySQL Workbench also provides you MySQL instance, because this is a background service which needs to keep on running in the background. So as soon as you start the MySQL Workbench from your machine, right, you need to provide the password, you need to provide the username, and then it will simply start it. And after that, this is how the interface will look like. And after that, I will guide you what are the meanings of these keywords which are written here and what all operations we will be performing and how we will be performing. So first part is the databases. So when we talk about transactional databases or database management system, so MySQL is what? MySQL is actually a database management system which provides all those kind of environments where we can manipulate the data by using some query language and typically used like the SQL. Okay. So first let me show you how we create the databases and what is the meaning of schemas here, so that you don't get confused, because the common keywords which are used across different databases, that is database itself, and there will be different databases where this keyword might get changed, like key space schema. So I don't want you to get confused with these terms. So in the MySQL Workbench, the meaning of schema is very simple. It is just like creating a different folder inside this ID itself, and inside that one we are creating different databases. So that is the simple meaning, and you don't need to do any sort of custom settings here. As soon as you start exploring it, you can definitely tune those settings, but by default, whatever interface it will provide, it's good to go. You can execute your SQL commands, queries, everything. So first and very basic thing, how we create the database in SQL, what's command we will be following. So the very basic thing you can see, right, these are the databases which I have already created for testing purpose, like DemoDB. Sys is something which comes by default, because this is what? This is a software itself. This is you can say Workbench, or it needs to store some metadata, right? Whatever things we are creating, whatever commands we are executing, so some default tables, right, as a root user will be set up, which different user cannot delete, which different user cannot manipulate. All right. So similar thing, we can see these are the default databases like sys, but this DemoDB, test2, testdb, testdb1, this is something which I already created, but here we will create a fresh one. So what's the command for that one? Create database, and we can give a database name here. So for that one, first demo. Okay. So you might be wondering how to open this notepad sort of file here. So we can click on this one, this left option in this menu bar, right, plus symbol. So what it will do, it will open a new SQL file. Like this is a blank file which you can see. All right. And this one which I already opened, and I have placed these placeholders so that we can follow a proper sequence of SQL commands, and you will be also able to relate it, how these things are executing step by step. So create database, first demo, and now how to actually execute it. Okay. So just select this portion from here and click on this thunder kind of symbol. Okay. So if I click on it, then here in the logs, you can see this log has been printed, how much time it has taken, or if it's a green check symbol, that means this command has been executed successfully. By chance, let's say this command was supposed to be failed, then we will also get a proper error message so that we can debug it and we can fix it. So here, since it's successful, right, now at this moment we are not able to see this database in this left panel. Okay. So what's the reason? Sometimes it needs to keep on refreshing itself. So what you can see this refresh symbol in front of this schemas keyword. So just click on it, and after that it is easily visible to you. This database has been created, first underscore demo. And if I expand it, then you can see multiple options are there: tables, views, stored procedures, functions. So this category is basically to provide a hierarchy in this ID itself, so that let's say we are creating few tables inside a database. As soon as we will create it, those will be visible here with the column names and its data type. All these kind of metadata information will be mentioned here. So after creating a database, we need to look at the command that how to use it, because different tables will be created inside different databases. So what's the command to go inside a database? For that one, we can write use database, and here we need to mention our database name itself. No need to use any database keyword, simply use and mention the database name. And if I execute it, right, this command is also successful. Now we are inside the first demo database, and if you have observed, there are multiple databases, but when I clicked on it, when I executed it, this is something which is now focus area, right? The bold section on the ID itself. So this is the cool part, I would definitely say. Now we have created a database, we have seen the command how to use it. Let's look at how to drop a database as well. Dropping a database, let's say earlier we were doing some stuff for our testing or development. Now that database is not in use, how to actually delete it completely. Okay, so for that one, we can use the command drop database and database name. Okay, if I execute this one, so since I have created this fresh database, I don't want to delete it. What I can do for my testing purpose, I can delete any existing database. Let's say I am trying to delete test_2, which I created previously. So test_2, let's execute it. Okay, now you can see this is also successful, and as soon as I execute it, it is removed from this left panel as well. All right, so the database creation part is done. Now we will move that how to create the tables inside a database. Okay, we created it, we used, now we are actually inside our first demo database. So this is the command to create a table in the database. These are the keywords which we actually need to follow, like create table. Okay, and after that we need to mention our table name. So each table in these kind of transactional databases is like a row columnar sort of data. Okay, so column name just like a variable which will have its own specific data type. So when we create the tables in MySQL databases, we need to provide few informations. So if you look at this entire command, this is a command we will be using to create a table. So after providing the table name, inside the parentheses, these parentheses, we are mentioning different column names, right? And after that, we are mentioning the data type. Then we are mentioning few keywords, which you might be wondering what is that and what is the reason to use these things. For example, not null, right? Then this is the keyword default. Okay, and this is another keyword, primary key. So let's try to understand one by one what kind of sequence we need to follow. So first we need to mention the column name, and after that we need to mention the data type. So different type of data types available in MySQL database. If some column which is supposed to hold the string type of value, it should be named like this, varchar. So when we define the data type as varchar, so by default it will pick some length, but if we want to customize this length, for example, this particular column will hardly take 10 characters. So we can simply mention this thing, right? And let's suppose we have different data types, for example, integer values, float values, double values, the date type of columns. So those type of data types are also available. Next thing, these are the keywords actually used to define the integrity constraints. So when we talk about the transactional databases, one of the important property is the consistency part. And we can keep the things consistent when we apply some rules. And that is something which is known as the integrity constraints in the transactional databases. And I have created a similar video on Scalar's YouTube channel related to this topic. And it's a long video where I have covered all the database management related fundamentals. So you can check that video here. So talking about the integrity constraint, not null and default is another type of integrity constraint. Let's say you have defined a column, and while inserting the values, let's say somebody is inserting null value, okay, and value is actually missing from that insert command. So by default, we don't want to keep this column empty. So what we will try to mention some default values, so that if somebody is providing null sort of values, this value will be populated with that particular default value. That is the reason of this integrity constraint. And similarly, you can see not null is something which has been used multiple times. So this constraint will prevent any kind of insert command which is trying to insert the null values, and that is the reason these rules keeps our database tables properly consistent. This keyword is something which is very much important. When we talk about the transactional databases, the concept of keys is super duper important, and one of the, you can say, most asked interview questions as well, like what are the fundamental of keys and why it is very much important. So the fundamental of keys plays a vital role in the data analytics databases, because when we try to keep our databases normalized, different tables will be created, right? And if there is no way to connect those two tables together, then it would be hard to do the data analytics or to perform any kind of database related operations. And that is the reason there are two main things with respect to the keys. First is primary key and second is the foreign key. So let's understand what is primary key. It is like a key element which we generate in front of each row, or you can say a combination of columns we can use from the table which we have created, and it is uniquely providing the identification to that particular record. Overall, what we can say, this is the mechanism or this is the keyword. Let's say we have a specific column in our table, for example employee ID. For each employee in an organization, they will be having a different unique identification numbers, right? Even two person having the same name, they might not be having the similar employee ID, right? So that is the same thing. It will help us to uniquely identify a record from a table. Second, you can see this is another table we have defined, and it is like employees. This table we defined for the offices, right? Here we are following same kind of integrity constraint, but another thing which I was talking about, the foreign key concept. So concept of foreign key is like, we can understand with a practical example, right? If somebody is visiting our country from different country, we call them foreigners, right? Because they are the primary citizens of their own country, but they are traveling in our country and just sort of reference. So same kind of concept. If we have more than one table and there is a key attribute which is a primary key of another table, and we are referring it into our table to establish that kind of connectivity which I was talking about. So in that case, we will be using this foreign key integrity constraint. So how to declare it? This is the syntax we can follow, like constraint name. So this is the integrity constraint. For each integrity constraint, we can provide a unique name, so that moving forward, if we want to add more integrity constraints, we want to alter it or we want to drop it, we can easily do that. So first we declared the name for this integrity constraint, then foreign key keyword. This column office code is something which we are referring in this employee table, and you can see in offices table, office code is a primary key, right? And that is what we are trying to establish. This kind of connectivity means references. So in employees table, office code is present here, and to establish that connectivity, we need to tell in this create table command that this column is present in which particular table as a primary key. That's what we have done here. So let's execute these commands one by one, and we will be able to see these two tables inside our database. So I have selected it, and as soon as I execute it, you can see this is successful. And if I just refresh it, then you can see one arrow sort of symbol has been created. And if I expand it, you can see offices table has been created. Now, if I expand it further, right, you will see this thing, this option for the column. So here office code is there, city, phone, address line 1, address line 2, state, country, postal code, territory, everything has been created. All right, this is done. Now let's create this part as well. So I have executed this command. This table has also created, and if I refresh it, we can see employees, right? So if I expand it, all these columns have been created, and you can also see there is an option of foreign keys. So if I expand it, right, you can see this constraint which we created, right? Employee IBFK underscore 2. That means this is something which is referring to the foreign key part. Cool. So we have created our tables. Now let's say we are inside particular database and we want to check how many tables are already there, and we just want to have a quick look at it whether table has been already created or not. Then what command we can use? So command is very simple, show tables. Okay, if I write it in this way and if I execute it, right, you can see this is how we are getting our result. So employees and offices, if you have let's say 50, 100 tables, all will be listed down here in the form of output. All right, so now moving to the next one. So after creating the tables, we saw that how to get the list of these tables. Now let's say we have created a table and we want to delete it, right? So there are three things to understand with respect to deleting a table or deleting a data. So there is a main difference. When we talk about the deletion, either we can delete the data only or we can delete the entire table structure. So there are three commands, right, which are typically related to deleting the data or the table structure. First is drop table, second is truncate command, and third is a typical delete query. So when we talk about the drop tables command, what it does, it can delete a particular table completely, including the data and structure, right? And when we talk about the truncate table command, it will simply erase the data, it will not delete the structure of the table. And same goes for the delete command. Let's say we have some specific requirement to delete specific records from the table. So for example, let's say you have an employee data and now you want to remove all those employees from some specific location. You can put some filter condition and easily those records will be deleted from the table. So first let's try to run this one. Let's say we have created these two tables, right, which we can see. I will just quickly drop it. I will write a command to drop this table first. Let's say the employees, right? So if I write the command, this is how it will look like, drop table and table name, right? And if I execute it, right, this is successful. Now in this left pan, right, you can see inside these tables now employees table is not present. All right, now if I do this thing, I apply the truncate command for the offices table. So this is how it will look like, truncate table, and our table name is offices. So if I use it and if I run it, let's check whether the table structure will be deleted or not. And at this moment, since we haven't inserted any data as of now, so if I simply run this command, ideally nothing will happen because our table is still empty, but we will verify whether table structure is gonna be deleted or not. So if I execute it and run it, this command is successful, but you can see the office table is still there. That's the difference, and this is also one of the most important interview question, the difference between drop command and the truncate command. All right, so first let me bring back the employee table again. So if I select it and execute it and refresh it, my table is back. Cool. So far we have seen the basic steps. Now let's understand how to put some data inside a table. Okay, so you can see I have already created a template to insert some bulk data inside the employee table and similarly in the offices table. So nothing to worry about. If you want to follow all these steps, this whole execution step will be provided to you. You can find this piece of code which I am writing here or the SQL commands. The GitHub repository link will be provided in the description and you can use all these commands as it is, whatever I have been writing here. So insert into then table name, and inside the parenthesis what we need to do, we need to provide the column sequence. So this is a typical syntax of inserting multiple records. So for an example, at this moment what I want to do, I just want to insert one single record. So how we can do it? So let me copy it from here and I will just paste it and will show you how we can simply insert one record and what is the actual meaning of this sort of bulk record. So this is the command we need to follow: insert into table name, and let's say you are pretty much clear about you need to insert data in all the columns. So in that case you can skip this part, that means defining the column names. You can completely skip this part because if we don't put this column sequence, this insert statement will understand it like you want to insert data for all the columns. And after that we need to use this keyword named as values, and this is important. So see, when we talk about the table, and here you can see, right, this office table has also a proper structure, right? These column names are not randomly located anywhere. So while even inserting a particular record, we need to follow this sequence. Okay, and that is the reason sometimes, let's say there are 50 columns in my table and I am supposed to insert the values for hardly 5 to 10 columns, right? So how to do it? Obviously we need to selectively provide the column names, and the column sequence which we are providing here, in the same sequence we need to insert the data as well. Else what will happen? We will get the exceptions of mismatched data type. Alright, so if I execute this command, and ideally it will insert this one record and we will evaluate it whether this is inserted or not. So let me select it, and if I run it, we can see. So as you see, when I executed this insert command, it is throwing an exception that cannot add or update a child row. And why is it happening? Because this is the first time we are trying to insert the data, and as we can see from the definition, this table, employee table, is actually referencing a column from this office table, right? So since this kind of constraint has been maintained, obviously the level of data insertion should be from parent toward the child. So in this case, what would be the parent table if we just consider this foreign key kind of relationship? Obviously the offices table. That means whatever values we are trying to refer in this employee table, first they should be available in the offices table. So instead of executing this command alone, first let me insert something related to this data, right? So first, I think I have clearly explained how we can insert one single record. You can just simply execute this command, and this is a variation of same insert command when we want to insert multiple records in one single insert statement. So in that case, what you need to do, only values keyword will be used once, and after that in the parenthesis what we need to do, we need to simply mention our column values, comma separated. No need to use this values keyword multiple times, just the records enclosed in the parenthesis. So first what I will do, I will quickly insert this entire data, and I selected it. As soon as I execute it, now we can see this insert is completely successful in the offices table. Now if I come back here and if I ignore this one single liner insert command and I directly try to execute this one, so we shouldn't be getting any kind of error now of inserting data in this table. So I have selected it, and as soon as I execute it, you can see this one is also successful. All right. So if I just refresh it one more time, and how to just get the preview of the data, let's say this is the amount of records we have inserted, how we can get the preview. Okay, so for this one, if I click on this thing, right, let's say employee table and the third option, so if I click on it, ideally we can see this is the preview of our data which we are getting. Ultimately it is running a select command, and I will specifically talk about this one as well, so don't worry about it at this moment. So this was about the preview. Now insert part is also done. We have inserted data in both of the tables. We will look other important commands in the SQL, which is, let's say, alteration of the table, because there could be multiple scenarios where we want to change the data type of any particular existing column, or let's say we want to insert a new column, right? If we want to perform these kind of operation, in that case we need to follow this syntax, right? The alter keyword. Okay, so here let's say if we come back to our table structure, there is a column, let's say address line, in the offices table, address line, and its length is 50, right? Its length is 50 at this moment. So what we can say, we want to run an alter command which will simply modify the data type or simply increase the length of existing address line 1 column from 50 to 100. So this is a modification in the table structure itself. So for that one we can use this alter command. So alter, and after that we need to mention the table name, which is the offices, and then our column name. So alter this one, and here what we are going to do, we are going to modify it, right? So modify keyword, alter offices, modify, and the column name is address line 1, and after that we simply need to mention the new data type. So this sort of thing can be implemented for other type of conversions as well. Let's say you have one column which is of integer type at this moment and you want to change it to the float or double, that kind of data type change we can also do it from here. So alter offices, modify address line 1, and the new data type will be varchar 100, right? And one keyword is missing, which is alter table, right? So the complete command is alter table offices, modify address line 1 varchar 100. So if I select it and if I execute it, we can see this is successful now. And if I click on it, if we come here and if I click on this column as well, okay, so how we can now identify it, that whether the data type has been changed or not. So for that one, so in order to see the complete structure of the table, what we can do, we can simply run this command, show create table and our table name. After that, what will happen, we will get the entire table structure, and if I execute it, right, we can see, let me just expand it so we can see the complete value. Now just focus on this part, you can see address line 1 has been changed to varchar 100. That is the thing which I wanted to showcase earlier. When we created this table, its type was varchar 50, now it has been changed to varchar 100. So similarly, if we want to add a new column for an example, so command is very simple, alter table offices, now add, and here we can mention a column name, right? Anything, let's say ABC or column 1 and just mention the data type, and after that simply selecting it, you can execute it and the new column will be added. So this is the syntax for that one. Now show create table we have seen the alteration of the tables as well. Now coming to the important part, which is to query the data which we have in our table. So in the beginning, when we started with the basics of SQL, right, we followed few sequence of the columns, right? So there are three categories of SQL commands as well, right? First is the data definition language, which is DDL. So data definition means any kind of SQL command which we are using, and it is trying to directly, indirectly impacting the you can say structure of the table, right? Let's say we are creating it or dropping it. These are the things, these are the commands which are eventually affecting the structure of the table, and even including the alter command. So that is related to data definition language. Coming to the data manipulation, so insert command, update command, delete commands, these are the commands which are actually manipulating the data which is residing in the table. Third is the data query language, DQL, and DQL means where we are trying to select the data which is inside the table. So this is important because most of the things will be done with this one, like how we can get the few selected columns from our SQL table, and how we can rename it, how we can perform different operations, right? So quickly look at the examples of it. So here, let's say from a given table, if I want to select all the columns, so the command is select star from table. So here, if I mention offices and quickly I execute it, we can see we are getting all the records from our offices table, right? So in total we inserted 7, we have in total 7. Now let's say what we want to do, we want to simply get starting 2 records or 5 records. For that one, what we can do, we can use the limit keyword in our select operation, and after that we can put some numbers, and only those number of records will be displayed in the output. If I select it and I execute it, you can see now only 1, 2, 3 records we can see in our output. Now let's say we only want to select few specific columns. So how we can do that? That is also pretty much simple. Just write those specific column names, and that will become the part of our final output. So here let's say we want to display office code and city only. So office code comma separated second column city, right? And now if I execute this command, we can see only office code and city has been displayed in the output. Looking at the third aspect of it, which is important. So this thing, how to rename a particular column in the output. Okay, so if let me just run this one again so that I can see all the columns. So here, let's say this is the postal code column, right? Normally we call it like a zip code or something. How to rename our columns in such a way? So for that one, the command is also very simple. So if I put it in this way, the second column is city, and after that the third column is the postal code. So I will make it postal code as. So this as is the keyword which we need to use in order to give some specific name to any of the column or any derived column in the final output. So I will name it like a zip code. Okay, and if I execute it, we can see this output where that postal code column has been changed to the zip code. Now another operation we will look at. So if I query this entire data of the offices table, right, we can see state, country, postal code, territory, all these things. So one of the common things, right, mostly when we talk about the data analytics, so let's say there are duplicate entries for any particular column in our table, then how we can get the distinct values out of it, right? So we have one important operation which we can use here, that is the distinct keyword on any specific column. So here in our data we can see country is something which has been repeated multiple times for different rows: USA, France, Japan, Australia, UK, right? So let's try to figure out, if we have, let's say, lakhs of records, millions of records in our table, and we want to just identify what are the distinct values in particular column, how to do that. So for that one we will use distinct keyword, and after that just mention the column name. So select distinct country from offices and just execute it. And we can also rename it. As I mentioned about rename, I can name it like distinct countries. All right, so let me execute it. We selected it and execution done. We can see now this one: USA, France, Japan, Australia and UK. Earlier there were 3 entries for USA in the input table. Cool. So we have seen this thing. Now another cool aspect of this select command, which is the data analytics related, means how we can apply the inbuilt functions. Let's say we have our data, we have the table, how to apply inbuilt functions like count, min, max, sum, average, standard deviation. So all these things are already provided in the SQL library. We simply need to use it on the respective columns. So I am going to write a select command which will calculate something, right, on the specific columns. Let's say finding the maximum, finding the minimum. And for that one, what I'm going to do, I'm going to use the employee table. So select star from, you can say, the employees table, and let's look at what data we have. So after selecting it, we can see this is the data, and this employee number is something which is of integer type. So definitely if there are numerical data types, we can apply count function on that one. Not just count function on numerical data types. Count is something which will help to count different type of things. Let's say how many rows are there, distinct count for the column values. But other operations like sum, min, max, average, standard deviation, this is something which can be only applied on numerical data types, not string sort of things, or the date type kind of things, correct? So select star from employees. Here I am going to use employee number to write a select statement where I'm going to do different operation. First, let's say I want to count the total number of rows which are present in our table. How we can do that? We can use this thing count star, and I can give a name to it, total rows. This one will calculate the total number of rows available in my table. Second one, let's say I want to find, because here you can see, right, these are the integer values, 1002 numerical values. So if I randomly try to identify what is the minimum value, maximum value, I can definitely do that. So for that one, I'm going to use, let's say, this min function, and I will pass the respective column name, which is employee number. And similarly I will name it like min emp num. And if I want to identify the maximum employee number we have assigned so far, I can change it to max, and it will be also renamed to max. Similarly, if you have another column, right, the example you can take here, the salary column in the employee table. Somebody asks you to identify total salary a company is paying to their employees, right? You need to apply the sum function. And similarly, you need to identify the average salary of the employees within the organization. You can simply apply the average function, right? All those kind of calculations will be done very easily. So this one we have already did from employees, and if I execute it simply, right, we can see total number of rows, total number of records we inserted 23. Minimum employee ID number was 1002, maximum 1702. So this is how inbuilt functions we can apply on different columns in the SQL table. Cool. So when we talk about the final output or performing the select queries, sometimes what we want as an end user, we want our data to be organized in some specific column names, maybe ascending, descending. So how to do that in the SQL? For that one, we will be using the order by clause. Order by clause, we can provide multiple comma separated values and their respective arrangement, let's say ascending, let's say descending, all those things can be done. So if I display our employee data one more time, we can see this is the data and how we can arrange it. So here if you look at the office code, right, so office code is something which is randomly, right, let's say 1 2 in between 4, then 7, then 6, then 5, then 4. Okay, so one arrangement can be done on this one office code in the ascending order. This is number one. And another one can be done, for an example, the reports to, right, reports to is basically the manager ID here, and manager is an employee itself, so this ID is eventually belonging to these number here. So this is how we can arrange our data. So let's see how to do that. First I will only apply this output on the reports to, not only reports to basically the office code column. So select star from employees, order by keyword, office code, right? So if we execute it, then let's see what happens, what output we'll get. So here now you can see it is properly arranged for us. 1 1 1 1, these kind of values are together, 2, then 3, then 4, then 5, then 6, then 7. So by default, when we apply the order by clause, it arranges our data in the ascending manner. So if we want to arrange this data in the descending order, what we can do, we can explicitly mention this DESC keyword, and now if I execute it, this whole arrangement will be done in the descending order of the office code, which we can see here. Now if we want to apply multiple level of ordering as well, so I'll give you an example how it can happen. Let's say you have employees from different companies and you want to arrange first your data in the form of the ascending order of country codes, okay, or you can say simply countries. So any country which is starting from, let's say, letter A, if you talk about the lexicographical order, those will be on the top, then starting from B, C, and so on. And there will be records which will be duplicated, and multiple duplicacy there will be, like the USA related records multiple time. And within that particular section, right, the chunk which has been created for USA employees, you want to arrange the data in the descending order of salary. So what kind of command you can follow here? I can show you the placeholder for that one. So select star employees, order by, let's say, country, and comma, second is the salary which is in the descending. So first what it will do, it will try to arrange the records in the ascending order of country, and if our SQL engine sees that there are duplicated records for the country, within that it will just arrange the data in the descending order of salary. So that is how it is going to work here. Okay, so now we will see how to filter the data set. If we have created our tables, how we can write that particular syntax which will give us some specific result in our output, and that is being called as our data filtration, or the filter logic, or filter clause you can say, but its technical word is where clause. And I will show you how we can apply selective operations like and or operation, like, in, is null, is not null, and there can be multiple ways we want to query our data with some specific conditions, right? So if we look at our employee data here, you can see multiple ways we can select the specific chunk of data, and that is the condition we need to mention. So for an example, here we can see office codes, right, and in each office, right, different folks from different designations are also working, right? So if we want to do some kind of selective search, it is easily doable. So let me write it in the way we can query the data. If we want to relate here, we can see reports to is something which is sort of a manager ID. So here we can see this employee whose employee number is 1501. He is actually reporting to 1102. So let's look at who is 1102 here. You can see Bonder Gerard is the employee who is the manager of this employee 1501, and its name is Larry Bot. Okay. So in the same way, right, a manager can manage multiple employees, right? So we want to query all those employees who are reporting to employee code 1102, or we can say Gerard. Okay. So select star from employees where, this is the keyword we need to use, where reports to, and we need to check what was the data type of this column as well. So here if we come back and we check, the data type of reports to is actually of integer type, right? So we can simply mention it as it is, because if it was, let's say, of a string type, we need to mention it in a different way. So reports to equals to, this is basically a equality comparison, 1102. Okay. So this is the filter condition we have applied. We are trying to identify all those reports. We are trying to identify all those employees who are reporting to 1102. Now if I select it and if I execute it, we can see, right, this is the list of all such employees who are directly reporting to 1102. So this is the one simple where clause implementation we have seen here. Now let's discuss what could be the syntax where we want to concatenate multiple conditions together, and that can be any logical condition, and kind of condition, or kind of condition. So let's try to do that, and for that one we will again look at our employee data, and we can see, right, these are the things which we can use for our practice multiple conditions. So here I'm going to apply this condition. First let me display the entire data set here. So if I execute it, this is the entire data set. Now let's try to check what we can use for our AND part. So we can see multiple designations like president, VP of sales, VP of marketing, right, sales representative. So here specifically if we look at this thing, the sales manager and sales representative, and these two people who are having these respective designations are working in office code 1. Office code 1 eventually having multiple designation folks, correct? So let's say if we want to filter out these records, so select star from employees where office code, and the office code data type is varchar, right? So what we need to do, we need to put it in this way, enclosed in the double quotes or single quotes, so that it will act like a string. So office code 1, and another condition, let's say from office code 1 we want to identify the employee number, name, etc, who is having a designation of VP sales, right? So second will be on job title equals to VP sales. Okay, here we can see VP sales. Now if I want to execute it, this is how it will look like. Okay, we can see this record only which we wanted to bring in our output, 1056 Mary Patterson actually working as a VP of sales in office code 1. So this is a AND condition. Okay, now if we want to apply the OR condition, okay, So how we can do that? Let's say if I display the entire data, there are two things. Here what we can do, either print the data of office code 1 or print the data of all such employees who are working as a sales representative. Let's say if we want to apply this kind of condition, how we can do that? We can use this similar thing here and we can just apply the OR condition. So or job title as sales, REP means representative, and now if I execute it, so easily we will get the records for the office code 1, or if any sales representative, right, who is having this job title will be in our final output. So if we have executed it, right, we can see the records from the office code 1 are definitely included, and from other office codes we are only getting the data of job title sales representative. And why it happened? Because of this OR kind of condition. Okay, so this is the another version, or now we will look at the how we can apply these kind of operations as well, right? Like this is another way of filtering the records based on some string pattern searching, right? Like in, is null, is not null. Okay, so one by one we will also check it. So this like operation can be done only on the string based or string type of data types. So select star from employees, where what we want to do, where we want to filter out all those kind of employees who are having a job title starting with sales. It can be sales manager, sales VP, sales representative, but what we want, we simply want all those job title employees whose designation is starting with sales, right? So how we can use this operation? Select star from employee, where job title equals to, where job title like. So this is the keyword we can use, and in the single parenthesis we need to apply that pattern matching. So that pattern matching is eventually related to this thing, means ideally it should start from the sales, after that it can be anything. So there are two wildcard characters which we can use. One is the underscore sign, another is the percentage sign. So when we apply this thing percentage sign after any of the string which we have written inside this parenthesis, so this percentage actually means 0 or more characters. So doesn't matter whatever is written after the sales, right? Let's say we can see sales manager NA representative, right? It will just look at in this way that this designation is starting from sales, and after that whatever is written I will simply pick this one. So that is how SQL engine will decide it. And now if I run it and if I execute it, right? So in our output we can easily see the data which is just related to the job titles which are starting from sales, nothing apart from that one. So this is also one of the important keyword we can say, or important operation in the where clauses. So this is the sales related, and now try to imagine multiple scenarios where you just want to pick the record. For an example, you have a data for different states and there is one column named as feedback or comments, and you want to search only those records where in the feedback some specific keyword is mentioned. So when there is a long text and you are not even sure whether that particular keyword might lie, so what we can do, we can put percentage before as well, and whatever text we want to identify, that should be in the middle, and after that we can also put the percentage. So how it will look like, sales anywhere in the particular string column value, and before that whatever words are there doesn't matter. After the sales keyword, whatever words and characters are there, doesn't matter. So for the example of that wildcard character, which is underscore, let's try to implement a condition where all those employee names, or you can say employee records, we want to fetch, whose first name is having only 4 characters. If this kind of condition we want to apply, so we are trying to strict something, we are trying to apply some strict condition on the characters present inside the first name. So here we will replace it as first name, and it will be like underscore 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 4 times. So one underscore represents one character here. So in this case, this filter condition will try to check that what are the employee records where this pattern is exactly matching with first name. So if we give a quick view here, we can see name starting with Mary, Jeff, right, and Louis, after that Mami, right, Andy. These are the names which are having only 4 characters. So ideally these kind of records we should get in our output. So if I just select it and execute it, you can see these were the records which I was talking about, we are getting in our output. So next one is related to the in operator. So in operator is just like a lookup kind of thing. So when we try to write those kind of queries where in the filter, or you can say where clause, we want to verify that something is specific to these particular values, we are getting the output in our final result or not. So in this case we want to apply lookup related query, and for that one we can use this in operation. So select star from this table, and here what I am trying to do, I want to just bring the data for the 2 office codes, let's say 1 and 6. So how we can write this query, where office code in 1 comma, I have also mentioned 6. So now you can see this will be acting like a lookup query. In this parenthesis I have mentioned only those values which will be used to evaluate the lookup part, because in our office codes we have seen different office codes are there, let's say 1, 4, 6, 7, and in this way when we will write this query, all the records will be scanned, and wherever the office code value is matching either with this one, either with this one, that record will be captured for the final result. So now if I just execute this one, and in our output we can see we are getting the data only for office code 1 and 6. After that, if I again present this data in front of this screen, and here you will see there are few records, right, or let's say this record itself which is having the null value. Okay, and I think for this example we should use the office data because there are multiple null values present. So if I write this query and we look at the office data again, so offices, and here is the query, and we can see multiple null values here. So that is something, if we want to fetch all those kind of records, and this is also a very important step in the data analytics, data cleaning and cleansing part, where we try to identify all such records who are having garbage, null type of values, we want to discard those things. So how to actually identify it? For that one we can use is null, is not null. Is null will be based on the filter condition where we want to check if this particular column is holding null value or not, and is not null is just a negation of that previous condition. So select, here we can see, let's say we want to identify all those records where the value of state is null. So how we can apply this condition? Select star from offices where state is null. Simple, this keyword we can apply here, and now if I execute it, in our output we can see these are the records or office codes where state value is not populated. And if we do just the reverse of it, that is also doable. And if I apply is not null, so we should be getting all those records where value of state is populated. So this is a very helpful thing when it comes to deal with the null related values in the table. So far we have covered most of the important steps, but still few things which are left, and that is the important part of the SQL commands. Like we have the data in the table, how we can update particular column values based on specific conditions. So let's try to have a look at it, how to apply the update command in SQL. And for that one, I will query the full data of employee and we'll figure out the specific conditions for it. So if I select it and if I execute it, so here we can see this thing. So let's say what we want to do, we want to change the job title of this sales rep to proper name, right? Sales representative. We want to change this entire thing. So what we can do, we can write a simple update command and it will be done in just one single step. So what's the syntax for it? Update which table we want to update, right? Update employees table. And what we want to do, we want to set some value to this particular column. So update employees, set job title equals to this new title, which is just a complete abbreviation for the sales rep representative. And how this update command will identify how many records I need to update, right? Let's say there is a need of updating the entire value. For an example, you want to just give the same designation to all the employees. You can even do it without any where clause, because at this moment if I execute this command, it will simply update or it will replace the designation or the job title with this value. But we need to do it selectively. So how we can do it? We can mention the where condition, that specific condition where the update will be applied. So update employees, set job titles equals to this, where job title equals to sales rep. So how this command is actually working? First, it will apply the where clause. It will identify all those employees where job title is sales space rep, and after that it will simply reset that value to sales representative. Now if I just execute this thing, so here we can see that it is throwing an exception that you are using safe update mode. So this is actually a safety feature in the SQL Workbench, because these update command is something which is actually related to some changes, and easily this can violate the safety feature unnecessarily. If somebody is trying to update the values, it can create the inconsistency in the table itself, right? So by default this safe feature is set to false, means if we don't turn it off, then we won't be able to update the records. And if we want to do that, we need to mention some primary keys. So first let's try to execute a command here, how we can just turn it off. For this one, SQL safe updates, this is the command we need to use, and we need to set it 0. And now if I run it, okay, this has been executed. So ideally after this option, if we try to run this update command, we should be able to do that, and that's had exactly happened here. We can see this is successful. And now if I query the data from this table, the employee table, select star from employees, so we should get the updated data now. So here we can see this name, which was previously sales rep, has been changed to sales representative. So similarly, this is how we can keep on performing these kind of update operations. Now looking at the delete command. So if you remember in the beginning, I mentioned about the drop command, I mentioned about the truncate, and there was one other way where we can do selective delete from our table with the help of this delete command. So for that one, how we can do it, what's the keyword we should use here. So for an example, from this table we want to delete all the records for the office code 1. This is something which we want to do, and we want to remove all the employee records which belongs to office code 1. So for that one, what kind of query we can write? So delete from employees, delete from employees where office code equals to 1. And if we execute this query, we can see this has been successfully executed. And now if I query this data again, there should not be any single record even related to office code 1, which we can easily see here. So that is how we can use the delete command to delete some specific rows from our input table. And same way we are using where clause, you can concatenate multiple conditions based on your need, what kind of the condition you want to use to delete any specific record. So now we will be looking at the most important operation, which is the group by, because when it comes to the data analytics, mean, median, mode, sum, average, this is fine, but we need to perform these kind of operations on some specific column values, right? And that is the very important part in the data analytics, and this group by operation is something which plays a vital role in order to perform these operations, because in this way we can granularize our data, we can granularize our output. Let's say we have our data from the e-commerce website where in a day millions of transactions are happening, and those transactions are happening from across the globe. So if you want to just identify from which country how much sale has happened for today, you just need to categorize this data. You need to create these smaller blocks, smaller chunks, so that you can apply that kind of average, sum, min, max, count related operations on that particular distinct values, and you can granularize your analytics. And for that one, we can use the group by clause in the SQL. So what is the syntax here? And first let's understand what example we will be solving here. So we can see, right, different office code values in our employee table. Now let's say if your management team comes to you and they ask you to give this analytics to them for each office, or let's say within each office how many employees are actually working. All right, so how we can perform this query? We can write it in this particular form. So I actually need to tell you one very important point, and that is why I'm not putting any column in the select operation at this moment. I want to complete the group by statement first, and then I'll tell you what is the catch with the group by operation. So leave it as it is. Now select from employees table. After that we will be writing this group by operation. So select from employees group by office code. We actually want to perform the group by operation on the office code column. That's why we have mentioned it here, and this part is done. So when we talk about the group by operation, in the final select statement, we can only use those columns in the final select statement which are part of group by keyword itself. Apart from that, whatever columns will be left, they can only be used with the aggregation operations like count, min, max, average. If we simply want to, let's say, select this thing, office code, and apart from that I simply write job title, so this will definitely throw an exception. Let me execute it. Right, we can see this is failing expression here, because the reason which I explained, the columns which are present here, this is actually not the part of group by keyword itself. So let's say if I'm using job title or any other operation, I definitely need to put it in the some kind of aggregation functions like min, max and all these kind of things. So here the main problem statement was to count the employees in each office. That's why we did a group by on office code. After that, we simply want to apply this count function, right? Normal count function if we are doing it, okay? And we will name it employees in each office. This is the derivation we are doing. And now if I execute it, all right, we can simply see this output. In office code 2, 2 employees are working. In office 3, 2 employees are working. In office 4, 5 employees are working, and so on. So this is the group by part, and it can be used with multiple things, and I can show you another alternative of it if we want to group by on more than one columns, whether that is doable or not. Exactly, it is doable. So let's figure out what kind of uh, columns we can actually use here for this sort of grouping. So for this example, we can see this office code and reports to. So see, manager is an employee of a company, and when you are a global company, what will happen? Different employees are working from different locations, and one manager which might be present in a different location can manage all those employees who are working from different regions. So that is the same kind of metrics we can see here. So this employee 1504, 1501, right, their office locations are different, right, 1370, but their reporting manager is same, 1102. So how we can write a query that for one specific manager, if I want to see how many employees are working from different reasons, means the grouping on the this level means the reports to, and this is the exercise we want to do for all of the managers, right? So if we want to do it, how we can apply this kind of multi-column grouping? So here our problem statement is we want to group it first on the manager ID basis. Within the manager ID basis, we want to group it on the office code level, and then we are counting the values. So here it is office code in the group by keyword, and after that we are mentioning, first we need to mention this reports to, and after that we need to mention this part which is office code, reports to, comma, office code. Now here what need mention here, reports to office code. Office code, and after this one the value which we have derived, that is absolutely fine, employees in each office. And now if we execute this query, right, we have got this output where we can see for, let's say, this 1102. So even the manager 1143 is also managing employees from different reasons. So that is how we can see the multi grouping can be done. Now let's look at the example where, let's say, we have created a chunk, means different groups, and after calculating the values in the group by operation, we want to filter out something, right? We want to filter out those kind of chunks where they are not following any specific condition. So along with the group by clause, we can use having clause as well. And having clause doesn't have any individual identity. It cannot act like a where clause, which is where clause when we talk about, it is actually like a independent entity. But this having clause can only be used along with the group by, not individually. So let's try to write some query where we are performing some operation, right? Here we can see our entire data set. So what kind of query we can apply? So let's say we are trying to calculate the strength of the employees in each office, and we are only interested in these offices where the strength of the employees is more than 3 or equivalent to 3, not less than that one. Okay, so how we can write this particular query? If I paste it here, this part which we have already written above, and here we will simply apply this condition. Okay, we are only interested in these kind of records. So here this query will be exactly same office code grouping we have done. After that we are counting the number of employees for each office code. But here what we can do, after this group by operation, we can write this having keyword and we can apply this condition. Count star means whatever count which has been calculated for one individual group, we are checking its value whether it is matching with our threshold value or not. That is count star greater than equals to 3. Okay, this is the thing which we wanted to evaluate. Now if I run this query, okay, here we can see only 2 office codes, 4 and 6, because these are the offices where employee strength is equivalent or more than 3. So now let's look at the last operation of our tutorial video, which is also the most important, the very important, the joins. So why joins are actually important? As I already mentioned in the beginning, the fundamentals of the keys, primary keys, foreign keys, because data analytics is not only about one table where you have everything and you are doing everything. It is always about creating a normalized database, and that will definitely have multiple tables. So we will be having multiple ways, different logics, different conditions to bring data together so that final informative report can be generated. Okay, so that is why this join operation is something which will be very helpful, and there are different type of joins available. The most important ones are like inner join, left join, right join, also full outer join. So one by one, first I will explain how inner join works. So if we go back and try to just display the output for employee and the offices table. So select star employees. Okay, here if we look at this data, we can see office code which was of string type, right? These values are present here. Now if I query this data, the offices, so here we will also see the full detail for each office based on the office code column, right? So definitely this office code is the important column based on which we can join these two data sets together. So first type is the inner join. Inner join means when we are using few key attributes for the join operation, so in the final results only those records will be present which are having the same values. If there is any mismatch for the values, those will not be included in the final result. So if you just want to imagine a Venn diagram for it, if you have two sets of number, so whatever will be the overlapped part or the middle part, that is the section we will be getting in the inner join output. So let's try to write the query for it, how we write the proper syntax to perform the join operation. So here what we are going to do, we are going to involve two tables, and there is a concept of giving alias name to the tables as well. How we can do that and why it is important? Because in the final select statement, we might be interested in few selected columns from table A, table B. So we should have some reference name or alias name which can be used here. So let's say employee table, we will give a alias name like EMP, and for offices table, we will give a alias name OFC. Okay, so that is why first I am writing the complete inner join part, and at the end I will be writing the columns in the select statement. So select from employees table, and the alias name is like EMP, just one single space, and after that whatever you are mentioning in front of the table name, that will be treated as a alias name. So from employees EMP, inner join offices OFC, and after that we need to mention this on keyword, because when we are joining the two data sets we need to mention which column we are going to use. Okay, and for this one, from the EMP table, there we also have a office code column, and we also have this column in the offices table. Okay, so the same column, you can see we are trying to join these two tables with the help of office code column. And even this is not necessary that column name should be same. Column names can be also different, but with the proper aliasing name we need to provide this referencing that in which table these two columns are present. So this is the condition for inner join, and as I said, now I will mention proper column names. So here what we want to do, we want to select all the columns from the employee table. So it will be emp dot star comma ofc dot start. Okay, now you can see this is the complete statement or syntax for our inner join. Now if I execute it, okay, in our output you can see there is a very big table which is involving all the columns from both of the tables, because we have done this kind of select emp.star ofc.start. But the interesting thing we can see, office code, right, the output which we are getting in our final result, the values for office code 2, 4, 5, 6, 7 is present, right? If you remember, in our office code table itself there was a code for 1, value 1, means there was one office where the code was assigned as 1, but for that particular code there was no record in our employee table. Here, using the delete command, we deleted all those employees who were belonging to office code 1, and that is the thing which I want to highlight, that if we perform the inner join, those kind of records will not come in the final output. Now talking about the left join, this is also another version of this inner join kind of thing. So here what will happen, again try to imagine the same Venn diagram, two data sets, and if you are using some on condition and there is a table which is on the left side, when we perform the join operation there will be a table on the right hand side. In case of left join, whatever records are getting matched properly, they will definitely become the part of final output. But let's say there is any specific value which is present in left hand side table, but there is no specific match for that one in the right hand side table, then in that case we will be getting the output from the right hand side table, but those values will be populated as null. Okay, so how we can change our query? Simply we need to change this keyword from inner to left. All right, so if we execute it, right, we are getting the data. But if you remember, in our employee table ultimately there were all such type of records for which match is definitely present in the office code table, right? So for an example, if we try to explicitly insert few records in the employee table which are not present in the office code, let's say office code 2030, we are maintaining entry in the employee table but those are not present in the office code, then this left join will give us the output, but the right hand side table column will not be populated. They will always be populated as null. Now if we talk about the last operation, which is the right join, for that one you can just treat it like a reverse of left join. So whatever thing were happening with the left hand side table in the left join, same thing will happen with the right hand side table in case of right join. So if there is a match, obviously those records will become the part of final output, but if there is a mismatch, then the records from the right hand side table will be there, they will be completely populated, but the records from the left hand side table will not be populated because there was no match available for that value. So how we can do that one? If I write this left to right and if I execute it, in this case we can see this one, this record is something which you need to focus on, because since we deleted all the employee records which were belonging to Office Code 1, that was the reason in employee table there was no employee record related to Office Code 1, but this entry is present in the offices table and we are doing a right join. So this is the right hand side section which is coming from offices table. It is completely populated, right? You can see this is completely populated, but the data which is coming from the left hand side table, this is completely null. And why it happened? Because there was no match for Office Code 1. So that's what I had for all the SQL basics command, and I'm pretty sure this practical implementation will give you the crisp idea how to set up this whole MySQL environment in the local machine system and how to perform all these basic operations with the dummy data. And as I said in the beginning, this entire code piece will be provided to you in the GitHub repository. You can find the link in the description and you can also practice the same things.
Hi everyone, I'm Naman Bhalla, and today in this video we are going to discuss about SQL queries and some of the common type of questions that appear regarding to SQL and basics DBMS knowledge that is required if you want to be good in DBMS. So the topic for today is SQL interview questions and concepts. Okay. So today we are going to first start with a basic coverage of different concepts that you need to know before you even start diving into doing SQL queries. You must know that, okay, how data is arranged, how to arrange data, how to structure your database in a good way, such that it is very fast on the queries that you have to do and all other things, okay? Great. So let us first begin with what even data is and why is data important, okay? The efficiency of any company, any business depends upon the data it has. Okay. I'm like the user data that you have, or you have the data about how people are behaving. And that information is very relevant for you to make business decisions. Okay. So data is of prime importance and at the core of a company's functionality. Okay. Now, how will you arrange data? To arrange data, you need some kind of system, right? What can be those systems? One very basic way to arrange the data can be, hey, that let me just actually create a file. And suppose I have a data and my data is something about, let us say that we are developing database for a system, okay, for a university. So what will be my data like? Let us say that I am a university. So my data can be like something about students, right? I can have some data about students. I also can have some data about my faculty, right? Or my employees. Let us say for now, let us keep it short and let us say that we have only data about these two things. Now, how might I save it? One way to save it is very rudimentary way that, hey, let me actually create a lot of files on my machine. And then in those machines, let me store the data. So let us say that there is a file, something like students.txt. And let us say that there is another file that is employees.txt. And then suppose you have multiple students. Let us say that there is a student who has a roll number 1 and his name is Abhay. And suppose he has a patch. Let us say that we are storing these three information. We store it something like 1 Abhay, and let us say it is 2016. So that is a very fine way to store data. There's nothing wrong with it, right? But is it a good way to store data? That depends. And that depends upon what kind of data that you have, right? So that is where the concept of a database management system comes. That, hey, how will you even store the data? What optimizations will you do so that the storing data is relevant to you? Because you don't just store data, you also use it, right? So you have to do some queries upon it. You have to also fetch the data back again to make some business decisions or resolve some queries, right? So there are two important decisions that you need to do. The very first decision is storing the data, and the second thing is querying that data, right? Without these two operations, our database management system is irrelevant to you. Okay. So our DBMS is nothing but a system software that allows you to store the data and query the data, along with providing a lot of security constraints and other things, which we will delve as we go into this video. Okay. So those are the primary two things that we need to maintain with us. Okay. So that is what a DBMS comes from. How can we structure a DBMS? One way to structure, I mean, like, how will a DBMS inside itself structure itself, right? So the one way can be like even a DBMS maintains a file. That is a fine way to structure. That might be something like it is maintaining documents. Okay. Can there be any better way to structure your data inside a database management system? What do you store the data about? In a computer, you store the data about some things, right? You store the data about something. Like here, you were storing the data about students. You were storing the data about employees. Suppose there is also users. You have some, let us say that probable students or people who have applied to you. So there might be something like applicants, which you are storing the data about. Okay. So you are storing the data about something, and for each student, for each thing that you are storing data about, you are storing some things about that thing, right? So these things that are called as entities. So entities are nothing but about what or about whom are you storing data. Okay. And about whom you are storing data, and what data are you storing, right? You are also storing some kind of data about things. Like for example, for students, you are storing the roll number, you are storing the name, and you are storing the batch ID. That depends upon the business decision as to what you want to store. So there are two things. The very first thing is the things that we are storing the data about, which as I told is called as entities. And then there is attributes or fields. What data about entities are you storing? Now, let us consider our real world use case. Is data in silos? No. There is always a connection between one data and other data, right? So, for example, for a student, let us say in a university, you might also need to maintain that which courses have been enrolled by a student. So, somehow you also need to maintain a course enrollment data set, right? So, let us say that another kind of entity can be course enrollment. For course enrollment, what do you need to store? You might need to know that what is the course number, and also you might need to store that who is the student who has enrolled for that course. So let us say the two things that you need for a course enrollment is nothing but a course represented by an ID, and also a student, which is probably represented by a roll number. Okay. Now suppose these are the three data sets that your university has. If we see here that, hey, we were maintaining the student roll number here, as well as we were maintaining the student roll number in the data set for this student, we were maintaining that roll number here. So data set is not in silos. Our data at what particular location has some kind of reference to data at other particular entity, right? Okay. This is known as relations between data. So now we observe one pattern in it that, hey, we are maintaining data about something, and we are also, because we have maintained data about different things, then we somehow need to maintain relations between them. So a database management system which stores data in the form of entities and the relations between them can be known as RDBMS, or Relational Database Management System. Okay. What kind of RDBMSs exist? There are different varieties of RDBMS that exist in the open source industry and are used very widely by different companies. Some of the popular examples can be MySQL, and another popular one can be PostgreSQL. Okay. Now, in these two terms, you would have noticed one thing repeating, right? You would have noticed one thing that was repeating was SQL. What is this SQL? This SQL stands for Structured Query Language. This can be considered as a default language, or I mean, like, it's not actually default, but it's one of the most popular languages to query upon the data that you had stored. Because as we recalled earlier, whatever data that you have stored has also needs to be fetched, right? I mean, like, if data is just stored, it's of no importance to us. It's just increasing your storage. I mean, like, it might be relevant to us in the future, but anyways, at one time we do need to assess it, and that is why we are storing it. Okay, cool. So now SQL, as we told, is the most important language that is used to fetch data from the relation RDBMS systems. Now let us see how SQL works. Okay. So the very first important thing that we see from SQL word itself is a query. What is a query? A query is nothing but a statement that you execute to fetch the data from an RDBMS. What is one important thing about computers? One important thing about computers is they do what you tell them to do, right? but they also require that you should be very well defined. You can't just say random things to it and expect that it will fetch you the exact results that you wanted, right? So you need to be very well defined. So you need to know that how do I write queries in SQL, right? Otherwise, you won't get the data that you actually intended to get from the SQL query. So the prime focus for the today's session will be how do we write SQL queries? What are the important constructs that we need to know while we write a SQL query? Most of the SQL functions in different DBMSs are almost same. So that is why we are going to abstract away from one particular technology of a DBMS. We are going to structure about common abstractions that we have in a DBMS management system, and then you can run those over any kind of system that exists. Okay. So the very first type of query, the very first important function or important feature to do a query is the select statement. This select statement is the most important thing that you need to know to run any query. What does select do? I mean, if we just go by the definition of the word, select means selecting something or choosing something from the data that you have, right? So that is the whole function of a select statement. So a very simple select statement can be that, hey, suppose you have a student table and you are maintaining three things about a student. Let us say that he has an ID, he has a first name, he has a last name, okay? And you need to know that, hey, who is the student who has an ID of 1? Suppose that is the thing that you need to know. And there are multiple students. Let us say the student with ID 1 has a first name of A and a last name of B. Then there is a student with ID 2 who has a first name X and last name Y. And you need to know that what is the first name and last name of the student who has ID of 1. So you basically need to know A and B. How will you use the select statement to write this? It's very simple. You will say select. What is this? This is first name. So I need to select the first name. What do I also need to select? I also need to select the last name. So select first name, comma last name. Where do I need to fetch from, right? So suppose someone asks you that, hey, you need to get this thing. I just tell you that, hey, you need to get suppose a biscuit. Where will you get that from? You will ask me that where should I get that from, right? So that information is relevant. So the next thing is from. Where should the query language get the data from? So suppose it gets from a particular table. The name of the table is student. So select first name, comma last name from student table. Okay. If you write just this query, what will you get? I mean, suppose you're a computer and someone tells you that, hey, you have to just get first name and last name from the student table. You don't know. I mean, like you go to the student table and you try to see that which first name and last name I need to get. You see there are a lot of first names and last names. So best way is that you bring all of them, right? If you just write this query, what will it return? It will return the whole table as it is. It will get the first name and last name of all the students. So basically what you will get will be A, B, and XY. Why did it return this? Because you didn't specify which first name and last name should the SQL get, right? Okay, so let us be more precise. Let us say that, hey, you have to select first name and last name from student of the person who had the ID 1. So you need to know that, hey, the ID should be 1 at that place. So you can write where ID is equal to 1. And finally, you can terminate this statement with a semicolon. Okay. So what will this return? This SQL query will return you A and B. And why will it return? This is because of three statements that we just saw here of SQL, that is select, that is from, and that is where. These are the keywords in the SQL query language. Great. So I think the basic idea about a select statement is clear now. Now let us discuss about a subquery. I mean, like we will be discussing multiple of these where clauses from in depth, but let us first discuss the basic high-level concepts before we delve into details. Let us discuss what a subquery is. Now, let us say that you need to give degree to some students. You are a university, you need to give degree to students, right? The students who are just going to pass in this particular year. Okay, now how will you give degree to those students? Suppose you have two tables. The one table that you have is a students table. Okay, in this students table, you have an ID, you have the name of the student, let us say, and let us say that you have batch. Okay, suppose this is a simple student table that you have, and you need to give degrees to the students who are going to pass in batch 2020, let us say. So then someone comes to you that, hey, some of those people who had the batch of 2020 are actually not going to get the degrees because they failed in some courses. Then you ask that, okay, where should I know that which students failed? So that person tells you that, hey, there is also a table that is failed students. In those failed students table, you have IDs of the students who have failed. Okay, so now you need to give degree to those students who have the batch of 2020 but have not failed. So somehow you now need to use what is here to give the result of your final query. How will you do that? To know which are the students who had failed, you need to select all the IDs of students from here, right? So somehow you need to select IDs from failed students. Okay. But the task that is given to you is not to fetch the IDs of failed students. The task that is given to you is to tell who are the students who are going to get the degree. Who are the students who are going to get the degree? Those are the students who actually have the batch, who actually have the batch of 2020 in the students table. So also, you know that you need to do this, that hey, select ID from students where batch is equal to 2020. Okay. So now you need to select those IDs from this students table where the batch was 2020, but you don't need to select those IDs that were present here, right? So what will you do? One very simple way, I mean, like one thing we will come to that in later of section of this video. There is also one statement which can do it in one line. But let us say, you can say that where batch is equal to 2020 and ID should not be an ID not in. And where should the ID not be? The ID should not be in the result of query of this particular thing, right? So ID not in, select ID from failed students, right? So here we saw that, hey, we used one select statement inside another select statements, right? This is also known as a subquery or a nested statement. By the way, this not in is a keyword in SQL where you can select those things that are not present in the result of a particular table as well. Okay, but now let us say that you ask me a question that, hey, how does SQL know that these and these are the same thing, right? I mean, like, how will it know that? I mean, there should be a basic thing that whatever data is here should be whatever the data was present in what was I mean, like, retrieved from the earlier query, right? So that is a constraint that SQL asks you. I mean, like, that's your responsibility to maintain that the data type of the data that is taken from here is equivalent to the data that is here. Okay, so that is what a nested statement is. Okay, now what kind of nested statements can be? There can be two kinds of nested statement. First can be correlated. What does a correlated nested statement means? What does a relation with two things means? Relation between two things means that, hey, one of those things cannot exist without the other thing, right? So a correlated subquery is a query in which none of the, I mean, like, in which this subquery, this is the subquery, right? Subquery is not independent, but needs the main query to execute itself. So it can't exist independent of each other. So if there is a correlated subquery, then what can be a different kind of subquery? The second kind of subquery can be non-correlated subquery. In which the main query, for example, in this particular query, this was the main query and this was the subquery, where main and subqueries are both independent. Okay. What do you guys think was the above subquery? Was it a correlated or was it non-correlated? As we can clearly see that in the above example, the select ID from failed students can exist without even the main query existing, right? So it is definitely an independent or a non-correlated subquery. Okay. Okay, so now we have discussed select, but now you also see that we were doing where, right? We wanted to check about, we wanted to do some kind of assertions that, hey, I need to know data about those things. I need to know the data where a particular where a particular thing is maintained, right? So let us discuss the common clauses. This where is known as a clause. Okay. So I mean, like, what is a clause? I'm like, in normal term, in normal real day life, you might have thought about clauses in your agreements or contracts, right? Those are the things that you need to check. Those are the things that you need to ensure. So where is also a clause. So let us discuss SQL clauses. Okay, one of the clauses that we have already discussed is where. There are three other main important clauses. Those clauses are group by, having, and order by. One of the best parts about the SQL query language is that, hey, each of the words in the language are actually very, I mean, like, self-descriptive, right? Because I mean, like, you just see the word and you kind of get an intuition that, okay, what might this thing be doing? What can the where thing be doing? Where clause just allows you to filter the records based upon some conditions. Okay, for example, what were the conditions in the original query that we had written? In the original query that we had written, the condition was that id should be equal to 1. Let us say that our data had multiple students, and those students, let us redraw a student table. In the students table, we again are having id, we are having a name, and let us say we are having batch. Okay, and let us say that there is an id 1, 2, 3, 8, 9, 11, 12. Okay, the name is A, B, C, D, E, F, G, and batches 2020, 2021, 2020, and 2022. Okay, so now I ask you that, hey, you only need to give me the students who have, the first condition is who are going to pass in 2020, that is, who have their batch as 2020. And the second thing, I also ask you that their IDs should be less than 10. Okay, so then what will your where clause have? Your where clause will have two things. What are those things going to be? Your where clause will have, first will be batch is equal to 2020. And what is the second thing? The second thing that your where clause will have, id is less than or equal to 10. So this is a simple where clause, and a where clause can have multiple things, multiple assertions that need to be maintained. And those assertions can be grouped with and. And if there is and, what do we think that other statement might be? I'm like, just similar to and. Suppose if I'm like, if we have done programming, there is and then there is a or as well, right? So suppose I had, instead of writing and, I had written or. What would the result of this query be? This query will result into all those students who either had a batch of 2020 or had an ID less than or equal to 10. So the query will return this. The query will the query return this or not? The query will return this. Why? Because the ID is less than equal to 10. So this will be returned. This will be returned because this is also satisfied. This is also satisfied. This will be returned because ID is less than equal to 10. This will be returned. This will be returned because batch is 2020, but this won't be returned because neither is batch 2020 or I did this. Okay, great. So that is where clause. Now let us discuss the order by clause. Before we discuss group by and having, because they are interrelated, first let us discuss the order by thing. What do we mean by an order? What do we mean by an order? Order is nothing but an arrangement of things in the way you want them to be arranged, right? Consider order by something similar to sorting. Okay. Now I ask you that, hey, please return me the list of all the students. Okay. I just tell you this thing that, hey, please return me list of all the students. You go, you fetch all the students and you return it to me. But in which order will you return? Did I ever tell you that? No, right? So there might be a thing that you ask that, hey, hi, in which order should I return it? So for example, let us take a normal use case. Suppose there are a lot of things in a restaurant, menu, and those things are grouped by being a starter or being the main course or being a dessert. Okay, suppose a starter is represented by a 1, a main course is represented by a 2, and a dessert is represented by a 3. Okay, now one person asks you that, hey, he has maintained in a DB table, he has maintained one starter one main course and one desert. Okay, suppose he has maintained a DB table, which is something like what will I eat, what to eat. Okay, so which is food ID. It also has food name. Okay, and also it also has food type. Okay, so food ID can be something, I mean, like suppose you are representing breads by something, you are representing some kind of pastries by something like that. Let us say there is a food ID which is 201, which can have a name of pastry, which let us say is a desert, right? So let us name it 3. Then there can be something he has selected 1. There are multiple things he has selected as main course, so there can be 2 things. Let us say that he has rice and he has some kind of meal or something. Okay, so then there are 100 or 120, and then there is one starter that he selected. Okay, let us say it is XYZ and it has 300. Okay, and this is a starter, so this is 1. In which order will the person like to eat? The person will like to eat in the order that he will have like to have, I mean, like he will have the main meal in between and then the dessert, right? Okay, so you need to, so you just go to the DB table and you say that, okay, return all the meals that the person had selected in what to eat. If you return the meals in the order that exists in the table, then you will actually disappoint the person like anything, right? So you need to return those meals in the order of what type of food they are. So you should return meal here, then you should return main course, and then you should return the dessert, right? So you need to order the meals that you bring by food type. So how will you do this thing? So you will say select food. Let us say you select the food ID. Where should you select those food IDs from? You will select those food IDs from what to eat. From what to eat. Okay. But in what order will you select those? You will select those in order of food type. So you will say order by food type. Okay. So then your SQL query will return this thing first, then one of those 2 things. I'm like, it can return any of those 2 because they have the same food type, and then it will return finally the desert. Okay, so this is the order by clause. Now let us discuss the other 2 things, having and group by. Okay, what is having and group by? I mean, like, what is the intuition that you guys get that, okay, what might having represent? Okay, so let us first think of group by. But let us first think of group by. Group by is a thing that is used by aggregate functions. Okay, let us should talk about group by here. Group by is a statement, is a clause that is mostly associated with aggregate functions. Okay, so what does this mean? Aggregate function means that, okay, those functions who actually compute upon a large amount of data and then return a result. So there can be 2 kind of functions, right? One kind of function computes upon a single argument and then returns a value. So those are known as scalar functions, which we will come to in depth again. And then there is an aggregate function. Okay, suppose aggregate function, the examples of aggregate functions can be sum, can be average, and those. Okay, so let us discuss about a simple thing. So let us say that you are using a having clause. So you want to know that you have to return those students, I mean, like, who lived in India and the student ID was greater than 5. Okay, so you need to return count of those. So what you will write? So you can say that select count of student ID, comma, country. So I mean, like, let us say that we had a DB table. In a DB table, with every student, I was also maintaining his country. Let us say in this student table, I had a country of first person was India, then this was USA, this might also be USA, this can be UK, this can be India, and this can be India, and this can be India. Okay, so you need to know that which are the people who have a country of India. So that is the very first thing to know. That, okay, so let us say that we need to know who are the students who don't have country India. Let us say we do the reverse. We need to know who are the students that don't have country as India. Okay, then you get the students. Which will be the students that you will get who don't have country as India? You will get this, you will get this, you will get this. That's it. Okay, but now you need to order them in some way. Someone tells you that, hey, once you have filtered those students who don't have country India, please group all the students that had a country together, right? So group all the students who had country USA together, then group all the students who had country UK together, and so on. Okay, so how will you do that? You will say that select count of student ID, comma, country from students. Okay, where What should be the thing? The thing should be that country is not equal to IN, because IN is representing India. Okay. Okay. Now you get all those students. Now you need to group them by countries, right? You need to group the countries that had USA together. Okay. So group by country. Okay. So all the students that have the same country are now together. That's it. Suppose you return this. What will this return? Now, what a group represents, a group basically creates a single group of people who had the same value here. Okay. So let us decipher this particular query one by one. Okay. In this statement, the very first thing is select from students where country is not equal to India. This thing will give you 2, 3, and 8. So you get these three things. Okay. Then the next thing that you do, you are grouping them by country. So then you get two groups, right? There are two students that had USA and one student that had UK. So now you will get two groups, which are 2B and USA and 3C and USA. And the final one was 8D and UK. Okay. So these two students were in the very first group and this student was in the third group. Okay. Now you have grouped them by country. Now what do you need to return? You also need to return the count of student ID. Basically, how many different student IDs were there where in each groups. So because count is a aggregate function. It works upon a different thing. It works upon a set of inputs and returns the number of inputs that are there. So what will be here? It will be 2. What will be here? It will be 1. So what will it return? It will return 2 USA and 1 student from UK. So writing this query helps you to find the number of students from each country where the country is not India. Okay, I hope that is clear. Now let us discuss having. Suppose I have written this query. Okay, and then I tell you that please return only those countries, where the number of students were greater than 1. Okay, so you need to return only USA and not UK. Okay, so having allows you to do filter on aggregate queries, filter on aggregate functions. So you can say that where having the count of student ID, so you can here write having count of student ID, or let us say ID, which is greater than 1. So if you write this thing, you are only going to get USA. So the difference between where is just a filter upon a normal attribute value, whereas having is a filter upon an aggregate function, the value returned by an aggregate function. So the question is why we use having instead of where clause in group by clause. So having actually used to, because see, once you have done group by in functions, then you need to do some kind of query upon these groups, right? So consider this as different, that you have done a grouping. Here you have done a grouping, and then out of those groups you are selecting particular groups that had something as this. Okay, so that is why you need to do a having. Okay, great. Now we had actually, when I was discussing this particular thing, that hey, let us say that we had to select the students who we were giving degree to. Okay, then I tell you that hey, we also don't need to select the students who actually failed. I told you that hey, we will run one query and then we will run a sub query, and the basically whatever the value was not in the second sub query, we will put in a not in clause and then give, right? This thing can be done in one query in SQL. So let us discuss three functions, which are union, minus, and intersect. Okay. By the way, I'm like, if you have studied set theory, these clauses seem very similar to what we discussed in set theory, right? Is there any kind of relation between set theory and why these terms are like that? Yes, there is. The reason for that is because the relation that RDBMS system, when they were actually originally the paper of RDBMS actually is representing all these things with notations of set theory. So an RDBMS is nothing but a implementation of set theory, that okay, how you will be doing operations upon data in terms of how you do operations upon set. Okay, so each table is actually a set and not ordered table. So that is why there is no guarantee as to how the data will be arranged in the table. it might happen that this data is somewhere here or this data is somewhere here, because these are sets and not tables. Okay. Achha. Now let us discuss union, minus, and intersect. What is union in a set? What is union in a set? In a set, let us say that we have two sets, A and B. In one set, we have three things, 1, 2, 3. We have four things here, 4, 2, 1, and 5. What is union of A and B? By the way, union in set function is represented by U sign. So what is AUB? This is nothing but 1, 2, 3, 4, and 5. Basically, union is the combination of all the values that is present in any of those two sets, right? If you also notice here that, hey, 1 was present here as well, but 1 was present here as well, right? But in A union B, we got 1 only once. So a union removes duplicates, returns duplicate only once. But what if you want to return, if 1 is present here and here as well, you need to return it twice. What if you want to return 1, 1, 2, 2, 3, 4, and 5? For this thing, there is a union all in SQL. Okay, union all keeps all the duplicates. Okay, so what the union statement basically does is union statements returns all the values that are present in any of the sets. Present in any of the sets. Okay, now what is minus? So I tell you that, hey, I have some things here. I have some things in this particular system, which is, let us say, A, B, C, D, and E. These are some things here. I tell you that you need to return everything that is here, but it should not be here. Okay. So what will you return? I mean, like, suppose, let us say that you have 5 things and 2 things. You need to return every of those 5, but those 2, but not those 2. So you do 5 minus 2, right? In maths, you do a 5 minus 2. Similarly, in sets, you can do a set A minus set B. Suppose this is represented by set A. This is represented by set B. If you do set A minus set B, you will get all those queries that are here. I mean, like, they should be here, but they should not be here. Suppose there was an F here as well. So what are the queries that are here? These are A, B, C, D, and E. Okay. And what is the second thing? The second thing is they should not be here. So out of these things, what are the things that are here? So they are B. So B will be removed. Well, that is A. So A will be removed. This is F, but F is not here, so we are fine. And the final return from here will be C, D. Now, do you guys think that we could have actually directly used this minus statement in the previous question? What would we have done? Instead of writing where not in, we could have just done minus here, right? So if we were doing here, we could have just done minus here and we would be fine. Correct? Great. So that is the minus query. And then what is intersect? Intersect is also a set function. And intersect between a set A and a set B is represented by an inverted U sign, and it says it returns values present in both set A and set B. So let us say that set A had the values 1, 2, 3, 4, 5, and 6, and set B had the values 2, 4, 6, 8. Now, if you do A intersection B, it will return those values that are present in both of those sets, right? So it will return something that are present here as well as here. So those are things like 2, 4, and 6, right? Great. Now let us actually, I mean, like, now we understand that, okay, what are these commands doing, but how will we actually write them in SQL? How will we use them in a SQL query? In these SQL queries, these statements are between two select statements. So how will it be represented? So one way can be that he select name from students minus select name from failed students. What will this query do? this query will return all those students, the names of all those students that are students but are not failed students. Now I tell you that you need to return everyone who is a member of my university. So suppose my university can have students and he can have employees, okay? And it can also have other things, but let us say that for now these are the only two things, and you need to return everyone who is member of the university community. So now you need to represent a union of those two things, right? Either that person can be a student or that person can be an employee. So what will you do? You will do select name from students union select name from employees. Okay. Now there can be one thing that, hey, I need to select those students. I need to select those students who are actually, let us say, living in a particular city, who are living in Delhi. Okay. Let us say, how will we do that? So we will say select name from students. Okay. Those are all the students, right? And then I have a different table. Let us say my database was arranged like this, that I had a students table and I also had a Delhi students table. Okay. So I need to select all those students that are first of all students. And the second thing that they are also Delhi students, right? So I will do an intersect. I will intersect with select name from Delhi students. So this will return me all the list of people who are present in this set as well as this set. Okay, as I discussed earlier, these terms are actually related to set theory, and an RDBMS is more of like sets and not of more like arrays. Okay, or what is a table. Okay, so these are sets. This is set 1, this is set 2, and this is a set operation of intersect. Okay, so there is a query that is it minus or except. This is a minus. Okay. This depends upon different database management systems as well. Okay, I mean, like, depending upon different DBMS system which are implementing, these concepts might be known by different names, but mostly these are known by the common terminology of union, union all, intersect, and minus. Okay, great. Now let us discuss one of the most important topics that are there in database management systems, that is joins. What is a join basically? Now, as we discussed earlier, that hey, data doesn't appear in silos, right? Some of the data might be here. Also, some information about that student might be in some other table, similarly, and so on, right? Let us say that we are maintaining data about an organization. Okay, let us say that we are maintaining data about an organization. So in the organization table, in the organization data set, we have first thing, we have employee table. And the second thing that we have is, let us say, employee salaries table. Okay. Okay. So now the thing is that I need to know the salary of a particular employee. Okay. I need to know the salaries of particular employee, or I need to return to you. Someone comes to you that, hey, please return me. Let us say that this employee table is storing ID, is storing the first name, he is storing the last name, and let us say that he is he's storing the role. So these are the 4 informations that are maintained in an employee table. And let us say the employee salaries is nothing but an ID and there is a salary. Okay. Now someone comes to you that, hey, please give me the list of all the employees along with their salaries. So now what you need to do is you need to return some data from here along with some data from here, right? So you need to return a group of things. So suppose that there was an ID 1, the first name was A, the second name was B, his role was, let us say, he is a CEO, and then the salary of ID 1 is, let us say, 10,000 some units. Okay. Then there is an ID 2, first name is A, 2 people can have the same first name, right? The last name can be C, and let us say his role is a VP. The salary of VP is something like, let us say, 8,000, and so on. And what you need to return? You need to return 1, A, B, CEO, and 10,000, 2, A, C, VP, and 8,000. So now you see that, hey, to return my answer, I need to actually fetch 2 tables. I need to fetch data from 2 tables. Okay. But how will you ensure that this data corresponds to this data, and this particular row, this particular record corresponds to this particular record? How did you come to know that? You came to know that based upon the ID here and ID here. You joined, or basically you selected those, you combined by the ID, where this ID matched, you combined those, right? This is the use of joins. It allows you to fetch data from two different sources, from two different tables, based upon something that matches. Okay. So now how is this happening? Let us discuss different type of joins when this will become clear. So the very first join and the most important join is the inner join. Inner join allows you to basically join based upon a particular column, and the data should be present in both of those things. So suppose there was a ID 3 and he had a salary of 6,000, but you don't see any employee with ID 3 here. So what is even the use of returning this data, right? So I mean, like, if still the same person asks you to return all the employees along with their salaries, you only need to return this, correct? Because you don't know if this 3 person is here. And let us say that there was an ID 5 and his first name was D, his last name was E, and he was also a VP, but you don't have his salary information. So you don't have his salary information. There is no salary information available here. So you only need to return those data whose information is available here as well as here, right? So this is the concept of an inner join. Okay. So let us discuss that how this inner join is going to work. So this is going to, I mean, like, the normal function, how do you write is that select star from first table. By the way, what is this select star doing? This select star does nothing but returns all columns of the table. All columns, okay? Not the rows. Okay? So we select star from table A, and then when we have selected everything, so basically I have selected everything from this table, then I also need to select everything from the employee salaries table, right? So then I will also select star from table B. Okay, but I need to join them. I need to join this with the second thing, right? How will I join this? I will see that, hey, ID here matches the ID here, right? So what I can do is, rather than doing this, so I say select star from table A. I select everything from the first table and I join. And I join with what? I join with table B. That's it. This is equivalent to select star from table A, inner join table B. So writing inner join is normally in most of the DBMS is not mandatory. Okay. So when you have done this, you get the result of this based upon these two tables. Why? How it automatically selects that what should I group by? It sees that, hey, there was an ID column here, there was an ID column here, as well as there was an ID column here. Because both of those columns had the same name, so it makes sense to, I mean, like, it makes sense to choose that as the common name and then group by that, okay, and then join by that. So that is the inner join. That is the most common join that is used. The second type of join is left join. This is a left outer join, but let us call it left join. What it says is select everything from left side, and if corresponding values are not there on the right side, fill those values with null. Let us take the above case. So suppose instead of doing an inner join where the value was present in left side as well as in the right side, I was doing a left join upon this table. So what would I be returning? So I will definitely be returning everything which was from the left side. So I will be returning 1, I will be returning 2, I will be returning 5. But there is no corresponding data for row 5 on the right side. So for those particular things, for all those values of this thing, I will put null and null in the salary. So what will I be returning? I will be returning 1 who has a first name of A, B, CEO, and his salary is of, let us say, 10,000. I will be returning 2, A, C, VP, who has a salary of 8,000. I will also be returning this because this is a left join. So I will be returning 5, D, E, VP, but I don't have any information about this, so I will replace this by null. So this is the left join. As there is a left join, so obviously the opposite also has to be true. So the opposite is right join. What this right join means? This right join means select everything from the right side. Now you have to do the first selection on everything that is on the right side. Now, if the corresponding data of the similar column is not available on the left side, fill the left side with null. Okay, fill the left side with null. If corresponding data is not available on the left side, fill the left side with null. So what will it return? It will return 1, it will return 2, it will return 3. For 1 and 2, there is the data on the left side, but not for 3. So what I will be returning will be 1, 2, and 3 are the IDs. For 1, I know the first name, I know the last name, I know the role. So this is CEO, and I also know his salary. Okay. For 2, I also know everything. So I know that his name is A, his surname is C, it is a VP, and it is 8,000. But there is a person 3 whose first name and last name I don't know. So what will I return? I will return 0. Sorry, I will return null, 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 and 6,000. So this is a right join. Okay. So we have done left join, we have done right join. What can be other thing? The other thing can be, if there is, select everything from the left side, select everything from the right side. If left side has corresponding data in right side, obviously do the join. But if there is no data on the right side, fill with null. Similarly, if there is something on the right side which doesn't have a corresponding data on the left side, fill that with null. So it's a combination of left join plus right join. And what will it return? It will return, and I'm like, it's known as a full join as well. Full join. Select everything, join if a match, else fill left side or right side by null, depending upon the situation. So let us see what will be the full join output for this particular table. I will be returning everything from the left side, right? So I will be returning 1, I will be returning 2, I will be returning 5. So it will definitely be returning at least these 3 things. Okay. But I will also be returning 3. So I will also be returning 3 because it is present on the right side, but it is not present on the left side. So I will also be representing this thing. So if you see, this is the output of left, this is the output of right. What is the output of a full join? Output of a full join is nothing but union of left and right, right? So basically, what will be the output of a full join? It will be 1 A, B, CEO, who has a salary of 10,000. Then there is 2 A, C, VP, who has a salary of 8,000. Then there will also be 5, whose name is D, E. Then he's a VP, but I don't know his salary. But I am also doing a right join, so I will also be returning this. So it will be 3, null, 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 and I know his salary is 6,000. So this will be the output of a full join. Now there is one more thing that that is also there. That is a cross join. So let us say that we have 2 sets. Basically, each select query is nothing but a set, right? So we have a set A and we have a set B. And there are multiple values here. Let us say they are A. These are different rows, right? So these are A, B, C, D. These are, let us say, F, G, and H. Okay. If we have 2 things, if we have 2 different sets and you have to make a Cartesian product or a cross product, Cartesian or cross product. Okay. What this means is that, hey, combine all the values from the left side with all the values of right side. So basically, what will be the final output? There will be this one row, these. So there are 3 rows. Similarly, there are 3 rows from here. There are 3 rows from here. And similarly, 3 rows from the final D. If there are 4 values in the left side and 3 values in the right side, how many values will be there in the final set of the cross join? If it is a cross join and one side has 4 values and the right side has 3 values, the final values will be nothing but 4 multiplied by 3. Why? Because each row on the left side is going to produce 3 rows, because it is going to be combined with every value on the right side and thus produce 3 rows each of those. So we will be getting 4 into 3, which is 12 as the final table. Okay. So there's a question that what if there are more than 2 tables? If there are more than 2 tables, you can use just parentheses to say in which order do you need to find the outcome. Okay. And all these functions are actually commutative. I mean, like union and intersection functions are commutative. So any of those order works. Suppose you have to do intersection of 3 sets. Okay. So then you can do select star from A. Then you can do union, select star from, let us say, B. Now, whatever all these values we got from here, then we need to do intersect, select star from C. So we can put this in parentheses so that this is executed first, then an intersection with this thing will be executed, and there will be an outer parenthesis as well. So I mean, like, we can group those statements together as we want them to. Okay, great. Now we have been discussing a lot different kind of joins, but what are we actually working upon? We are actually working upon the data. We are actually working upon getting the data. Suppose you have the data, what is your main idea? I mean, like, you want to get that data as fast as you want to, right? I mean, like, you want that, hey, please get me the data as soon as you can. Okay, so you need to ensure that my queries should run fast. How will you make the queries run fast? I think everyone must have heard about arrays, right? Everyone must have heard about arrays, and you guys would have also heard about hash maps. What is the difference between searching a value in an array and searching a value in a hash map? Searching in an array is a linear time operation, whereas searching, I mean, like, if the array is not sorted, and searching in a hash map is probabilistic order of 1, right? Okay, so what we observed from here was that, hey, in a hash map, we use some kind of different space or some other optimization or some other conversions to improve our search time complexity, right? Yeah. So if we want to optimize, if we want to speed up our queries, we can probably use some other memory. We can use some memory to speed up our queries. Okay. Using some memory to speed up queries is known as indexing. Okay. Now let us say that you know that, hey, a lot of times, I need to find all those students who had total score greater than 80, So suppose you have a table, suppose you have a student table in which there is an ID, there is a name, and there is a total score. Again, recall that, hey, SQL is not a array. SQL is a set. Okay, and there is no order in a set. A set can be returned in any random order. So suppose there is an ID student here who has a name A and whose score is 60. Then there can be 2 whose name is B, whose score is 10. Then there is a 3 whose score is 90, and let us say his name is C. Then there is 4 whose also name is A. It can happen that 2 people have the same name. Then it's also 80. Then there is 5 whose name is L, let us say, and his score is 5. Okay, now always there are a lot of queries that come that, okay, each query you have is that, hey, find all the users, or find total number of users who had sum or who had score greater than equal to X. If it was an array, I mean, like, if suppose this was the final data set that you had, and you knew that you are getting a lot of function calls just finding score greater than equal to X, would you like this data to be arranged in some kind of order? You would like that, hey, if this data is sorted by the total score, right? If this data is sorted by total score, then you can answer each of these queries using binary search in order of log n, right? So you need to do some kind of post processing. Okay, and also you need to know what are the common operations that your database has, or what are the common queries that your database has. So this is known as a database indexing. What is an index? First of all, an index is nothing but a data structure. To study which is a data structure that actually does that is not the scope of today's lecture, but if you want to study that, you should definitely see about that B tree and B plus trees. What are these? So this is how indexes are actually, I mean, like, most of the times implemented. So an index is nothing but a data structure that provides quick lookup. Okay, because you need to arrange the data. I mean, like, hash table is also nothing but a data set, right? So quick lookup based upon a query, based upon queries in a column or a set of columns. What do I mean by set of columns? Why set of columns? Okay, sometimes it can happen that, hey, suppose a lot of times that you have queries that are actually not just based upon a particular column, but are based upon a conjunction of multiple columns, right? That all the students who have a name beginning with, let us say, B, and who had a score of less than equal to 80. Okay, so then you probably need an index upon 2 columns, which can be name, and the second thing can be total score. So how to choose which will be the columns that you will index upon? That that depends upon what your application is doing. What data is your application assessing a lot of times? If you see that a particular data is being assessed a lot of times, it makes total sense to add an index over those particular columns. How will you create an index, by the way? To create an index in SQL, you run this. So you run a statement like this, create. So by the way, I mean, like if you ever have to create something in SQL, you use the create statement. If you have to create a table, you use this. You have to create a database, you use this. In this time, you have to create an index. So you do create index. You can also name the index. Okay, I mean, like you can call the name of index, something that you want to do. So let us say that I call this index name score. So I create an index whose name is name score. Then I also need to specify what are the columns that I'm creating that index upon. So I'm creating that index upon columns that are name and total score. But these columns can be present on a large number of tables, right? These columns can be present in a lot of tables. How to decide that which is the table I'm talking about? So I also need to mention the table. So I will say on students, name and total score. So if I run this particular query, it will create an index upon these two things. What is the disadvantage of an index though? The disadvantage of an index is that it needs extra space, but that is fine. An extra space is not a big issue, but it can slow down writes. So let us say that, okay, let us say we don't know about B trees or B plus trees, but you had to actually implement an index yourself. Okay, if you had to implement an index yourself on this particular thing, you can say that, okay, I will always maintain this table in sorted order of table score. And then if insertions happen on this particular table, what will be the time taken to insert? It will be linear, right? So I'm like, because you always need to ensure that the table is sorted. So then you can't do it in order of one or in constant time. So indexes can slow down writes because they need to process the new data that it achieved. Okay, that is an issue with indexes, but otherwise they are actually always beneficial. Okay, great. Now, what kind of indexes can be there? The indexes can be of two types. I mean, there are two ways in which you can classify indexes. The very first way in which you can classify indexes is unique and non-unique index. What does unique index says? Unique index basically allows you to maintain that if a particular data is if there is a duplicate in a particular column or in a particular set of columns of the data. Suppose you have a data in which you want to always ensure that no two students have the same name. No two students have the same name. How can you do that? To do this thing, you can create a unique index on name column of students, right? So what will happen is that at any write, whenever a write happens, it will check the index if a constraint that was set in any of the indexes is being broken or not. Okay, if we had not indexed this thing, checking this would have been a more complex operation or a more computationally expensive operation. But as we have maintained an index over that particular column, it immediately allows me to check that if that constraint of uniqueness is being broken or not. Okay, so unique indexes are there to ensure some constraints in there. Then what is the definition? I mean, like, why is there a need of non-unique indexes? Non-unique indexes exist to speed up the query. So while unique indexes, the main purpose of unique indexes is to maintain the constraints or data integrity, right? They need to ensure that the data integrity is maintained, but the function of non-unique indexes is only to speed up the queries. Okay, and that is the biggest advantage that non-unique indexes have. Okay, now there is also another way in which we can classify the indexes. This way is known as clustered and non-clustered indexes. Okay, the very first thing that I told you was that, hey, a relational database is not a table, but it's a set. Okay, so that means there is no definite order in which the data would actually be stored in memory, right? It could be stored in any way. Okay, now if I tell you that my query is always to select people in order of their roll numbers. If I say that I have a student table again, okay, I have their roll number, and let us say that I have their name. And I tell you that my queries are always going to be selecting students in the order of their roll numbers. But as the databases are set, so the roll numbers can be arranged in any order. So 3 can be here, 2 can be here, 4 can be here, and like this, name is A, name is B, name is D, let us say name is C. Okay, so data can be arranged in this order, but I tell you my queries fetch students always in order of roll numbers. Now, what would you like to have? I'm like, will there be something that makes immediate sense that, hey, if my queries are always fetching data in the order of roll numbers, should I arrange my data in the order of roll numbers? If I have arranged my data in the memory in the order of roll numbers, it will speed up my queries, right? Because then I need to just iterate over the data and I'm done. Okay. So what clustered indexes allow you? Clustered indexes, they change the way data is stored in the database as per the index. So if I create a clustered index based upon roll number, what will it basically do? Inside the memory, inside the storage where the data is actually stored, this will change to 1, 2, 3, 4, and 1 has C, 2 has B, 3 has A, and 4 has D. So now, if my queries are always in the order of roll numbers, they will become very fast. Okay, so that is what clustered indexes are. But what are non-clustered indexes? Non-clustered indexes maintain a separate data structure to optimize queries. Let us just see only this definition of clustered indexes. If clustered indexes change the way in which data is stored in the memory, can I have more than one clustered index? No, right? Because if I have more than one clustered index, then I need to store the data inside the memory as per the conditions of two indexes, which is not possible, right? Because there can be only one way in which I can dictate the order the data has to be stored in the storage, right? Okay. So one issue with or basically one thing with the clustered indexes is, the very first thing is that there can be only one clustered index, while there can be multiple non-clustered indexes. Okay. The second difference between clustered and non-clustered index can be that the clustered index changes the order. Clustered index affects how data is stored in memory, while non-clustered indexes don't. Okay. 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 Let us say that we have these two things. If we have a clustered index upon a particular column, and also if we have a non-clustered index upon a particular column, which of those do you think will be faster? If we have a clustered index, basically because clustered index is actually directly affecting the data set, right? And it is storing the data in the way you are assessing. Also, you have a non-clustered data set. Which of those do you think will be speeding up the queries more? Obviously, the clustered index will have even faster queries, right? Clustered indexes have faster performance with respect to non-clustered, okay? Because in a non-clustered index, you actually first talk with a different data structure, and then that data structure depicts that, okay, now fetch this data, now fetch this data. Whereas in a clustered index, the data itself is stored in that manner, and thus it helps you to speed up those queries. Okay, great. Now let us actually talk about something called as views. What are views? What a view is, let us say that I need to have one source of truth. Okay, so I say that there is always one source of truth, and a lot of times I'm storing data about students again, let us say, and I am also storing their gender. I have students, suppose I have their ID, I have their name, I have their batch, and I have their gender. Okay, so let us just write few things. A 2020, gender can be male. 2, which can be P, which is 2020, gender can be female, and P can be A, let us say C, whose batch is 2018, who can be, let us say, again female, and 4 can be T, 2019, can be male. Okay. Okay, so this is the data that we have. Okay, now what I tell you that there is one person in my university who ensures that whose job is to ensure to do data analysis upon the data of females. Okay, suppose her job is that, okay, let me actually analyze the data of females, do some operations with it, try to find out some information from it. Okay, how can I ensure that the purpose, that the repeated task of that particular employee in my company, whose task is only to just do multiple queries upon the data of females. Okay, so this is students. Then one way can be that I create another female students table. So one can be that I create another female students table, and that female students table will be like this: name, batch, gender, and then there will be 2P 2020 female, then there can be 3C 2018 and female. That is one way in which you can do that. Do you guys realize that there is some issue with this? There is some issue in which the data is being arranged here. The issue with that is, now if a new student gets added, suppose there is a new student that gets added whose ID is, let us say, 5, name is E, batch is, let us say, 2019, and she is also a female. Now we don't just need to put the data here, but we also need to put this data here. Okay, and if by mistake you forget to put this particular data at this side, then the employee whose job was to ensure the data, I mean, like, to do some operations or analysis over the female data, will go wrong. Okay, so what would you ideally like to have? You would ideally like to give the employee who is working upon the female data a view, a subset view over the students data, right? That, hey, he can see what is the data of students, but only that subset of the data of students where the gender was female, right? That makes sense. How can we do that? We can do that by creating a view. So a view is nothing but a select statement, that gives an intuition of a different table, while in reality data is present only at one location. Let us see how this works. Like, suppose we have this data only, then what will a view do? A view will actually, let us say that this is, it kind of like is a camera over that thing, that, okay, it allows you to see this thing but with a filter. So here, this view is, let us say that the female students is no longer a table, but female students is a view. This view behind the scene is just running a select query, which is just selecting those students from the students table that have gender as female. But the employee whose task was to work upon female students can now use it as she would have instead used a female students table. That is what a view does. So view basic. And now what would happen? Now if you ever do a write here, now if you add a new thing, you just need to add it here. As soon as you add it here, this view will automatically get updated because there is only one single source of truth. Okay, awesome. Now let us discuss some of the, how can we do the where clause? Okay, we have a where clause, right, that we have discussed. One way in which we have used the where clause till now is using equal to's, right? Using directly checking for equality or checking for less than equal to and all those things. Let us discuss something called as wildcard patterns and other things that you can use in the where clause. Okay, so where clause, let us say pattern matching. Okay, so in where clause pattern matching, let us discuss different kind of things that can happen. The very first thing is wildcard patterns. Suppose a complaint comes to you about a person, and the person who actually did the complaint didn't know the exact name of the person who did the crime. Okay, and then what he tells you, that I just know one thing, that, hey, his name starts with KH. That's the only thing that you know. Now you can't just do a DB query. You can't just do a SQL query where name is equal to KH, something like that, right? So you would like the name. So you want to do a SQL query where name starts with KH. Okay, how can you write such query in SQL? In SQL, you can have pattern like K percentage. What KH percentage means? This means KH and followed by any sequence of vectors. This can represent KH. This can also represent KHA. This can also represent KHAY, and similarly, right? Great. So this is what a percentage or a wildcard pattern is. So how will you use this wildcard pattern? Suppose the task that is given to you is find all students whose name begins with KH. Okay, suppose this is what the data that is, the question that is given to you. And the data set is something like this. This is the student table. And in this student table, you have an ID, you have the name, and you have, let us say, batch. That should suffice. So there is a student with ID 1 whose name is Khyati, and the batch is 2016. Then there is student name number 2 whose name is, let us say, Aman, and whose batch is also 27, let us say 2017. Then there is student 2 who is Khayal, let us say, that might also happen. Then his batch is 2016. You need to find all the students, and let us say that there is also one more whose name is Kamal. Now, what will this query do? So we need to find all those students whose name starts with KH, right? Whose name starts with KH. So that means we need to return this, we need to return this, and that's it. Okay, we don't need to return this because this starts with KA. So what SQL provides you? The SQL provides you first the wildcard pattern, and the second thing is a like statement, is a like keyword. So you can write thing like that, hey, select star from students where name. See, when we actually know the exact name, we use the equal to sign, right? But now we don't know the exact name. So instead of equal to sign, we have to use like, where name like, and then I will say KH percentage. I hope that is clear. Okay. Now, rather than finding all the students whose name is KH, I tell you that, hey, the question is changed, but I need to find all those students in between their names. Suppose AMA is coming. Suppose I need to find all the students that have AMA in their name. Anywhere in their name. I mean, like, it might not be the starting characters, it might not be the ending characters. What can be a real world use case? Suppose what do we say that, okay, I mean, like, an examination is going on, and the invigilator finds a chit, and the invigilator finds a chit. On that chit, the name of a person was written. It was AMA. Now the invigilator wants to know who might be the students, who would have done, whose chit that might be. Okay, so now you need to find all those students that had AMA in their name. How can we do that? To find all those students that had AMA anywhere in the name, we can write percentage AMA percentage. So what this percentage symbol is representing, basically, if we see from this particular thing and from this particular thing, is any sequence of 0 or more characters. Okay, so this percentage AMA will match Aman. This will also match Naman, but this won't match Amit. Okay, so what can we do? We can just write a statement, select star from students, where here we wrote where name like this. So here we can write where name like percentage AMA. Now, we had also discussed a thing like, I mean, like, in the very beginning of this video, that if we want to remove a subset of the queries from my statement, right? So I had used a not keyword, right? What this not keyword allows you to do, this not keyword allows you to omit those results present in something else. So let us say that my query just changed. I somehow know that, okay, the person who had did this, the person who did this thing, his name just doesn't have AMA. That's the only thing that I know. Okay, then what can I mean, like, how can I find all those students that had, how can I find all those students that didn't have AMA in their name? I have to find all those students that didn't have AMA in their name. I can just use this not keyword. I can say select star from students where name. First we were doing where name like. Now we don't want the name to be like something, right? So we can say where name not like percentage AMA percentage. So if we run this query, this will return Amit, but this won't return Aman. Okay. Now we have discussed three things. We have discussed percentage at multiple places. We have also discussed not. There is also a specific sign, okay, a wildcard for a specific position. That is nothing but the underscore sign. Okay, what it says, suppose I want you to find all those people, all those students, the third character in whose name was, let us say, M. Okay, so if I only want you to find all those students, the third character whose name was M, but anything else can be anything else. Okay, so I want to return Naman, and I want to say, let us say that there is something called Lambot. I need to return this as well. I need to return this as well, but I don't need to return Amit. Okay, suppose this is what I want to return. Okay, so how can I do that? I know that the first two characters can be anything. Then there should be an M. Then there can be any number of remaining characters. Okay, if I write percentage M percentage, will this work? No, this won't work. Why will this not work? Because this will also return Amit. Because Amit also satisfies percentage, M, and all this as percentage. So what can I do? I can say that the first two characters should be underscore. So underscore matches any character, any single character. Okay, so first two characters should be underscore, then there should be an M, then there should be percentage. What this means is that the first two characters, so that numeric value, that there should be a percentage, then there should be an M, that should be a percentage, that is fixed. So I can find all those students who had the third character as M by something like select star from students where name like slash underscore underscore M percentage. Okay. Now let us take talk of another question. Let us talk of a question where I had to return all those students whose name had more than 4 characters. I had to return all those students whose name had more than 4 characters. How can you do that? If the name has to have more than 4 characters, we know that the first 3 characters can be anything. The first 4 characters can be anything. So we can just write that by underscore, 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 underscore. That means the first 4 characters can be anything. Then it can be percentage. I mean, there can be any number of characters after this. So a query to select all those students who had name greater than 4 characters can be something like select star from students where name like underscore 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 and percentage. Okay, so that was in wildcard pattern searching of strings in a database. Let us also talk about what kind of database, I mean, like what kind of operations can actually have can happen on a database. Because if you are using a database management system, you need to know what are your requirements, right? What kind of data that you want to have, okay, or what kind of operations happen, or what kind of requirements are there from the data set, so that you can choose a database system that actually conforms to those requirements. So there can be two kinds of database management systems that are commonly known. The first type of database management systems are OLTP, and the second thing is OLAP. So how to distinguish between these two? You can distinguish between these two types of data sets using the word T and A. Okay, what does T means? T means transactional. What does A means? A means analytics. Let us try to understand the difference between OLTP and OLAP. So as we see from the name that OLTP database is more for transactional things. Okay, what do we mean by transactional things? Transactional thing is a large number of queries, but each query is very small. Okay, I mean, like let us say that very simple thing. Let us say that I just need to select all those. I mean, like I just need to increment the value of something by 1, or let us say that I still have the students table and I have their marks as well. Let us say, so I have students tables, I have their marks. Let us say the student table has something like this: ID, comma name, comma marks. Okay, so there is ID 1, A, initially his marks are 20, then 2, B, 30, something like this. Okay, so now my queries are things like, hey, my queries something are like that, hey, insert a value or update a value, things like that. These are very small operations, but these operations are happening a lot of times. in those scenarios, you need a transactional database management system. So what that transactional database management system will need to do, it should have actually a very fast response time. You will be very sad if just to create a like, if just to submit a like, it takes a lot of time for the Facebook's database system to actually store that like in the DB and return you that, okay, you have liked that post. Okay, let me actually just tell the full form of these things. OL stands for online and P stands for processing. So online transactional processing and online analytical processing. Okay, so this is the difference between OLTP and OLAP. Okay, so in an OLTP database, I need fast response time. Okay, so my CPU requirements are not that much, but I need to be able to serve a lot of requests in very fast. Okay, so normally OLTP databases are actually distributed. Okay, because you need to serve a lot of requests or a lot of parallel requests which are normally short, so you actually distribute your load. Whenever you actually have to have a lot of small queries, the best way is that you distribute those things and have multiple different computers handle it rather than having a vertical scaling approach. Okay, whereas consider you are a company, consider you have a database of a lot of users being stored since long. Okay, and then every 2 months or every 1 month, at the end meeting, you do a very big processing over those database. You try to find all those users who had posted more than X messages, or you find all those students who had actually attended more than 5 classes, and then who had actually also solved more than X contests and solved those. Okay, so in online analytical processing, these databases are useful for business analytics and intelligence. Smaller number of queries happen, but each query is quite complex, can be quite complex, we will say. Okay, because I mean, like, one query might be fetching from a lot of tables and doing a join between them and trying to find a lot of other things. Also, in OLAP database management systems, other things that are actually, I mean, like, if you're doing a business intelligence, visualization becomes very important, right? So visualization, etc., are common features. Okay, so in this thing, being distributed is one important aspect, but in this thing, having a large support for visualizations and other thing is a more important task. Okay, now let us actually talk about a very important thing in database design. I mean, like, how will you even create I mean, like, how did we decide that what tables do we need to create, or what do we need to store in what table? How did we decide that? Let us discuss this. Actually, this is a very important topic as in terms of database management systems, in terms of understanding database management systems. This is normalization. Normalization allows you to have good database design. Good database design in terms of what? In terms of how we are arranging entities and relationships between them. Okay, so normalization also allows you to reduce data redundancy. Okay, let us say I had the student table again. In the student table, now I'm also storing the address of everyone. I'm also storing the address of everyone. Okay, so let us say that student has ID, he has a name, he has a city where he lives, he has a pin code, and these are the things that I need to store. Okay, so let us say that this is a database. So let us say that we have ID1, his name is A, he lives in Delhi, and his pin code does not live in Delhi because Delhi has multiple pin codes. Let us say he lives in a city XYZ that has only one pin code, and let us say that the pin code is 110001. Then let us say that there's a student 2 whose name is B, who lives in city ABC, and the pin code is 133001. Then there's a student 3 who also lives in city, like, whose name is C, who also lives in city XYZ, and the name is 110001. Okay, suppose after a few days, government decides that, okay, we will be changing the pin code of the city XYZ. What can happen? What can be an issue in this database design, this database schema design? The issue can happen is that, suppose government says that the city with XYZ will now have a pin code of 127201. Suppose this is the pin code that the new pin code of XYZ has to be. Now, if this happens, what you will have to do is you will have to go on this student table Everywhere where 110001 is there, you have to change 1 to 7201, you have to change 1 to 7201, and all those things, which is a very bad design, right? What can also happen is that suppose there was also another student C, let us say G, he lived in city XYZ and had a pin code of 11001, but you somehow forgot to change this. And that's a bad thing for you. Now your data at some places is storing the pin code 127201 for the city XYZ, but at some places it is storing 110001. That means the data is not consistent. What do we mean by that? We mean irregularities in the information. So what would you ideally like to have? You would ideally like to have is that, hey, all these cities, I mean, like the city and pin code, because a city can be recognized just by the pin code, right? So I would ideally like to have is that somewhere I'm maintaining the pin code and the city name. If I am somewhere maintaining the pin code and the city name, I can ensure that these consistency issues are reduced to minimum, right? So what will be very good for me is that let me have a ID, name, and pin code here. Or let us say, instead of having one table storing this, I can have a student table that only stores ID, that stores name, and that stores city ID, right? And I have another table, which is city table, that is storing city ID, city name, and pin code. Now we have 1A and let us say 1 here. Also we have 3C and 1. We have 4D and 1. Now we have 2B and 2, let us say. So we can say that the city ID 1 has name XYZ and has a pin code of 110001. City ID 2 has name ABC and 133001. So now if government decides to make the change, you only need to make one change, that is here. And this thing will automatically conform to new changes that happened here, right? So this is the advantage that you get by making your designs of databases very good. Okay, so these are known as normalized databases. Okay, but how will you decide that there is a need to improve the database design? Let us discuss normal forms for that. There are 6 normal forms actually, but greater than 3 normal forms are not actually used much. So we will be discussing here 1NF, 2NF, because those are more prominent. Let us discuss what 1NF says. A 1NF data, a table or a database schema design is known to be satisfying 1NF if there are no multi-valued attributes. What do we mean by no multi-valued attributes? Suppose you have a library management system, and in a library management system, you store which books have been allocated to a particular student. So you need to have a table, let us say allocation table, in which you have a student ID and you have a list of books. Okay. So suppose there is a student whose ID is 1 and he had bought and he had rented, let us say 5 books. So those books had ID 101, 120, 113, 120, and let us say 121, and let us say 180. Okay. So there can be a student 2 who has rented 3 books, let us say 11, 113, and 21. So on. This database schema design in which any of the table can have more than one rows is, in which any of the column can have multi-valued attributes, because this attribute has multiple values. This is not just a single value. This is not just an atomic value. So this does not satisfy 1NF. So how will we convert this data into 1NF form? We can change this data into 1NF form by splitting this data. Like this. Student ID and books, and say 1, he has 101, 1, 120, 1, 113, 1, 121, and 1, 180. Similarly, 2 has 11, 2 has 113, and 2 has 21. Okay, this data, this satisfies 1NF, this does not satisfy 1NF. Okay, so that is how you convert a data set that is not satisfying 1NF into a data set into a schema design that satisfies one normal form. Let us discuss about second normal form as well. 2NF data, I mean, like the exact theoretical definition of this is that there should not be any column, or a set of columns that can be uniquely identified, by anything other than the primary key or the candidate keys. I mean, like, what are the primary keys and what are the candidate keys? We will discuss in a moment. But let us take care of this thing. Let us see the example that we had here. Let us see the example we had here. What was the primary key of this table? Let us firstly define primary key as a row, as a column value that has to be unique. For any record in the table. So, for example, if we see, the ID has to be unique. I mean, like, no two students can have the same ID. That is the main source of distinguishing between any two records. Okay. So what it says is that, let us see this pin code and this city thing. Do we think here that pin code actually doesn't need this ID to be uniquely identified? Pin code can be uniquely identified if we just know the city. But city is not the primary key, right? I mean, like, pin code can be identified by the city, but city is not the primary key. That means there is a subset of columns in my schema design that can be uniquely identified without even the primary key, which is ID. So how can I convert this data set into second normal form is what we just did here. But the conversion that we had done here was nothing but the conversion of a data set that does not comply with second normal form into a data set that complies with the second normal form. Let us actually take one more example. In which we can do that. Okay. Suppose, let us say that this example is actually present also on the interview practice forum of this. So what it says is that, hey, let us say we have a students table. We know the student ID, we know their name, and we also know if he's a Mr. or if he's a Mrs. Okay. Then we say that, okay, let us say that we have students, we have ID, we have name, we have gender, and we say that what is the salutation that we use for them? Okay. So let us say that salutation can only be Mr., Miss, or let us say it can be Doctor. Okay, these are the three salutations that are allowed. Okay, can we somehow know these three things by some other thing? I mean, like, let us say that currently I'm maintaining students like this. One whose name is A, whose gender is, let us say for now we have only Mr. and Miss. Okay, we name it A and gender is male. We have student B whose gender is female. We have student 3 whose gender is A, whose name is B. This salutation will always be Mr. This will be Mr. and this will be Miss, right? But actually what we realize here is that, hey, if we just know the gender, we actually know the salutation. So what happens if I suddenly decide that I will call all the males not Mr. but suppose Master? I might decide that. Then I will have to iterate over the students table. and update this and that can lead to consistency issues. So this is where, I mean, like, if these are the two columns that can be uniquely identified by something other than the primary key, we split these set of columns into a different table. So we split this by only maintaining gender here. So let us say that we are maintaining ID, name, and we are maintaining gender ID. Okay, so we are saying 1, 2, 3, she is A, he is B, he is A, then gender is 1, 2, 1. Then based upon gender ID, I can store the name. I can also know the salutation. So I can say that gender ID 1 is male and the salutation is Mr. and the gender ID 2 is female and the salutation is Miss. So this is how I convert a table or convert a schema design that's not into the second normal form into something that is a second normal form compliant. Okay, great. Now let us discuss one last thing before we actually end today's lecture, is something called as procedures. Okay, something called as procedures. In normal functions, when you would have, I mean, like, in normal programming that we do, we don't just write code sequentially, right? We don't write code sequentially, but we actually make our schema design procedural. right? We say we have a function called print this, we have a function called do specific task to ensure that a SQL code, that means our normal program is modular. Okay, that should look modular. Okay, how can we do the same thing in SQL? In SQL, we have something called procedures. Procedures are nothing but select statements. They are also select statements that can be identified by a function call. We can create procedures, and each procedure is doing nothing but a select statement. Okay, so each procedure is doing nothing but a select statement. They are select statements that are identified by the name. Now, these procedures can be something that also manipulate the data, right? They can actually change the data as well, that whatever is in the data set at that particular location. So suppose there can be a procedure, or this can be update statements, modification statements. Okay. So example, the one example for that can be, suppose this was the thing that happened, that hey, you decided to call all mails master. Okay, suppose you decided to call all the mails master. Now what you will do, you can write a procedure, which is called change salutation. It can take in gender, and it can take it new salutation, right? And then this recursively runs the SQL query and then changes it. Okay, now when we are actually discussing this, let us actually discuss what kind of SQL statements we have, that we have. And let us actually parallelize its intuition with how you build a house. When you are building a house, what are the things that you need to do? Okay, I mean, like when you are building a house, first you need to decide that, okay, how will my house look like, right? How will my house look like? So that is basically definition. Okay. Then the second thing can be who will live in the house, right? Who will live in the house? Okay. What can be the other things? The other thing can be you put something in there, right? You actually put some value there or put some data here and all those things, right? So the other type of queries can be that, hey, you manipulate or you change the design, that you say that, okay, I will put one more thing in the kitchen, or I will do these things. Okay. So those can be what we say controlling it, or we can say it as modifying it or manipulating it. Okay. And what can be the fourth kind of thing? The fourth kind of thing can be that, hey, you have manipulated, you have queried, you have you have defined the thing, you have queried, you have manipulated. You also say that who is going to control the thing, like who has what access. So these are the four things that are actually in SQL, these are the four kind of statements that exist. The very first kind of can be data definition language. These statements allow you to define how my data is going to look like. That, okay, this is going to have something like this is going to have something like these. These statements are create and all the statements. Okay, these can be create, these can be drop, these can be truncate. Actually, not truncate. Truncate is not actually a data definition language. Then the second thing can be query. For querying in a database, what are the statements that we had actually used? One most prominent statement that we used for query in a SQL database was select. So that is a SQL statement that is used for selection, for query, right? And the third thing can be manipulation. These manipulations can be insert, update, and all those things, right? Insert this, do this, and all those things. Okay. What is one more important thing? One more important thing is who actually has access. Who actually has access to my table? Because data is very private, so you can't give the access to everyone, right? So you need to have some kind of control of who has access to the data. So in a SQL, the database administrator actually gives you a control that, okay, there is a user this who can actually create who can actually write to this data, or this user cannot write to the data but he can only read. So these control statements can be grant and revoke. So in a SQL, all the statements can actually be segregated into these four things. There can be a definition statement, which can be creating, dropping. This can be querying, which can be like select. This can be manipulation, inserting something or updating something. And these can be controls. These controls are allowed, these control statements are there to, give some read rights, or only write rights and all those things to the database management system. Okay, so these are the four things that are there in this. Now let us actually discuss some, some tricky kind of thing. Let us discuss one tricky question that is normally asked in a database interview, and then we will. But the question is that, hey, you have to create a new table with structure, with exact data structure of another table. Okay, suppose there is a table called students, and you don't know that there is a table called students. You don't know this. Okay, so there is a table called students, but you don't know what is inside this table. So there is, suppose, ID, there is name, there is 2-3 more things, but only you know that there is a table called students, and you need to create a table called students copy, which should be having the exact same structure as the students table. Without knowing that what is the structure of students table, how can you do that? So this is actually a very tricky question that is normally that can be asked. So like, how can you do this thing? Anyone has any ideas here? Let us try to see what a select statement was doing. Select statement actually returned me whatever the data was present in my table, right? So if I don't know students table, at least I can run this select query to get the data in that form, right? So I can still get select star from students. Okay, but then what will I do? Now I at least know that what is in the data. What is the structure of students table? But what should I do now? What can I do? I need to store whatever was the structure that came from here into some other table, right? So SQL allows you another keyword, which is into. I say I select star into student copy from. Now where am I selecting from? I'm selecting from students, right? Okay. What will this thing do? What will this statement do? If my statement is only this particular thing, what is this going to do? Into does nothing but copy everything that was in the first table as it is to the next table. Okay. So for example, if students table had 1 A XYZ, 2 B ABC, and 3 C D E F. Okay. So this statement, this is the students table. This statement will actually just copy everything as it is into the students copy table. Okay. But I don't want the data. I only want this structure. How will I do that? I can say, because I have written a select statement, then I can have a where clause, right? Okay, I will have a where clause, but what to put in the where clause? I need to put something in the where clause such that none of these rows actually get carried forward here. So the statement should be something that is always false, right? So that nothing from here gets carried forward here. So what can that statement be? One very hacky thing is where 3 is equal to 4. This statement can never be false, right? This statement will never be true. This is always false. So select star, when the select star thing gets the table structure, it creates a new table, student copy, because you are putting into here. So it creates a student copy, but because the where clause was never satisfied, we actually never put anything there. Okay, or actually we could have done where 0 or where false. That would have also worked perfectly. Okay, great. Now let us actually discuss some of the aggregate functions of the in SQL that are present in the SQL, because that is something that people tend to miss out, because otherwise you have to see the documentation. Let us quickly discuss that, and then we will be ending the today's session. So let us discuss aggregate functions in SQL. Okay, so let us just list them down, and let us see what those are. The very first function can be average, AVG. So this function takes in a list of values. And returns the numeric mean of them. Okay. One more function that we had actually discussed in the beginning of the lecture, in between the lecture, was a count, right? Count statement returns just the number of rows, or the number of records that are satisfying that particular statement. So if I just do select count of star from students, what will this do? I'm saying the count statement just returns the number of records that satisfy my select statement, right? So if I have select and I'm saying select everything from students. So what is the count of everything? This is nothing but number of students. So one hacky way to get the number of records that you have is just select count star of students. That was perfectly fine. Okay, let us discuss other functions. That is min. Min also works upon a type of data. Then there is max. Because there is average, then obviously there also has to be a sum. There is first and last. What are the first and last doing, by the way? I mean, like, people tend to get confused by first and last. What is the, I mean, like, how are they going to be decided? They're going to be decided by the order in which the rows are returned. So the first will return the first element in the order in which select statement would have returned the values. Are null values counted? Yes. I mean, like, if the whole row is null, but it is still present, so yes, that will be counted because that record is still there, unless you have maintained primary key constraint, in which that case it will anyway fail, right? Yeah. So similarly, the last fetches the very last particular record for that particular element. Okay. When we were in the middle of the lecture, what we found about that? What did we observe about these aggregate functions? These aggregate functions allow you to group by. I mean, like, they are used with group by and having, right? So these are the aggregate functions. When you aggregate upon something, when you are doing an aggregate. So let us say I am going to take average of all males. Suppose the question that comes to you is that, hey, given a student table, where student table is something like ID, name, gender, and score. Okay. You have to return average of males and females respectively. Okay. So the very easy question, very easy version of this is that, hey, I just need to return the average of all the students. In which case you can just do select average of score from students. But now you have to select average of males and female in different groups. How will you do that? In that case, you will have to group those students by their gender, right? You will have to group the students by their gender. So you will still have to select average of score from students. But now all the students are not one group. All the students are not one single group. There are multiple groups. And how are those groups being made? Those groups are being made by their gender. Okay. Select average of score from students grouped by gender. Okay. So this is how the group by statement comes into effect. I hope that is clear. Okay. Now let us actually discuss these are the functions that are aggregate functions. These are working upon a set of data. There are also other functions. I mean, like, many people feel that, okay, it's very difficult to, I mean, like, it's normally a better choice to use a programming language along with, I mean, like, SQL. Otherwise, it's difficult to write a lot of things. But actually, SQL has inbuilt scalar functions. So what are those scalar functions? These take in one value and return one value. So basically, like in multiple programming languages, suppose you have a capitalized function, right? Suppose, like, let us say in Python, you have a capitalized function. Actually, let us write those functions in SQL only, so as to not confuse people. So let us, in SQL, there is a function called uCase. If this function is nothing but this takes in a string and returns uppercase version of the string. Similarly, there can be lowercase as well. Okay. Then there are multiple other functions. There are concatenation of different strings. Then there are some mathematical functions which are actually useful. These are rand for random. Then there are round. One of the most important functions that I've actually personally used in my, in real life environment is the timestamp functions. So, like, if you are working with, let us say, data warehousing solutions like Redshift and all those things, timestamp SQL functions are very actually useful. So these can be like to timestamp. Then there can also be now function that returns the current date and time. So one thing, like, most people think that SQL is just about the query language, it's just about querying, but it actually has a very strong set of inbuilt functions that are available directly that you can use and do a lot of tasks that you can actually probably do with only programming. I mean, like, obviously you can't do a lot, many of them, but I mean, like, it's more than what normal people think to be. Okay, one thing actually we missed out in the medium of the lecture was keys, right? We actually missed discussing them in detail. So let's just throw a brief light on them, and then we'll be ending it. Let us discuss primary keys and foreign keys and how to create those and foreign keys. Even before we discuss primary keys, let us actually discuss a term called as candidate keys. Candidate keys are a set of column values which can uniquely identify every other value. Select a set of columns, actually, set of columns which can uniquely identify every other value in a record. What do we mean by this? So basically, let us take care of a student's key. Let us take care of a student's table again for the last time. So let us say the student has an ID, he has a name, and let us say he has marks. Okay, and that's it. Or let us say even as a gender. Okay. So let us say the student with ID A has name A, score 20, and gender M. Then ID student 2, he has name B, he has score 30, and gender female, he has 23, he has name C, 31, and male. Okay. So suppose I just tell you the ID of the student. If I just tell you the ID of the student, you can directly go and say that, okay, the student with that ID had this name, had that score, and that male. Okay. So I mean, like, if you just know the ID, you can know all these three things, right? Let us only consider this table, the current values in this table. Do you think in this current value, name will also be uniquely able to identify all the other attributes? If I tell you that please get me data where name is A, please get me data where name is A, will it be able to uniquely identify all the values? Yes. In the current set, it will be able to, because there is only one person with one name. So A has only one person, B has only one, C has only one. So if I only know name, I can directly get the score, I can directly get the gender, and directly get the ID. Is gender enough? Is gender enough to get the data? No. Gender is not enough to get all the other values of the data set, because there are multiple people who have the gender male but have different name, different ID, and different scores. So the columns, that is for this example, name and ID, that can uniquely identify every other values are candidate keys. So candidate keys can be a single column or a set of columns. What is primary key then? Primary key is the key that the DBMS uses to uniquely identify a record. Okay. It can also be a single column, or it can be group of columns. Okay. So let us see the student and books table that we had actually written above, right? Above we had actually written a student table where what we had was that, hey, which student has rented which books. So there we had a student ID and book ID, right? So if student 1 had taken book 201, he had taken book 202, he had also taken book 203. Then student 2 has taken book 101, he had also taken 202, he had also taken, let us say that there is a student 3 who has taken 203. Suppose these are the students and this is the table. What do you think can be a primary key of this table? Can it be only student ID? Can it be only student ID? No, because there is no, I mean, like, if I just tell you student ID, you can't uniquely identify the value. This student ID is associated with this book ID. I mean, like, there is this thing, this is also associated with this is also associated with this. So basically, primary key can be can be the set of columns whose value, if you know, you can uniquely identify a row. You are guaranteed to return a single row. Okay. So for this particular table, the primary key will be student ID, book ID. Both the columns together constitute the primary key. And let us actually discuss how will we create a primary key. I mean, like, in a SQL statement, how will we create a primary key? To create a primary key, you can either do, the very first way which you can do that is while creating table. So while creating table, you can do create table. You tell the name of the table. Let us say that the name of the table is students. We create table students. In this table, we are actually maintaining student ID and book ID. Let us talk about this thing. Let us say here we maintain the ID as this. Okay. So when we create a table, we have to tell what is the name of the column. And then we also have to tell what is the data type of that column. So let us say that ID is an integer. Okay. And I mean, like, let us for now keep it as it is. Then we say that, okay, we are also storing a name. Name is nothing but a string, right? In SQL, a string is a varchar. It's a variable character of how many characters max? Let us say it's 255. So at max, that can be 255 characters. And then here we have, let us say, score, which can also be an integer. And let us say we finally have a grade. I mean, like, let us say we don't have a gender for now. Okay. Then we have to decide the primary key. So we can write primary key, and in the parenthesis, we set what that primary key is. Okay, that is one way. While we create the table, we actually write what is the primary key going to be. But suppose you had actually created the table and you forgot to add the primary key. What will you do? If you forget to do something that you had actually written while creating a data or while defining the data, you can use the altered keyword. Altered keyword is used to alter the initial data definition that you had done. So you can do alter table students where and you first you say that I am now going to alter my table. So that means I'm going to add something to it. What I'm going to do, I'm going to add primary key, and that primary key is going to constitute only ID. That is how I use the alter keyword and get this particular thing done. Okay, so that is about the primary keys. Let us actually briefly discuss, I'm like, before we come to foreign keys, let us actually briefly discuss the constraints. Okay, so I also want that, hey, I tell you that there should not be any student whose name is empty. Okay, I don't want any student whose name should be empty. Okay, that means I want that student's name should definitely be present. So SQL provides us a list of constraints that we can use upon our data definition. Okay, so one of those constraints can be unique. Then the other constraints can be not null. Then there are other constraints like that can check a particular value. That, okay, unique constraint says that value in a column or a group of columns should never be duplicated. Okay, not null says value should never be empty. Then one of the constraints that we have discussed is primary key. That primary key by default says that it should be unique and it should be not null. Okay, then there is also one more constraint that we can say default. So I tell that, hey, if I somehow miss to give the value of a particular column, please set it to this value. Please set it to the default value. Okay. Then one thing can be check. This check statement can actually verify that a value is satisfying a particular condition. For example, I can say that suppose I also had a gender here. So I can say that it's a gender and it's in character. Okay. Then I can maintain a check that, hey, gender should be only M or F. Okay. So this is what this is what we maintain by gender, that, okay, I put a constraint that, okay, there's no predefined constraint. So let me actually create my own constraint that, hey, the value of gender should only be M or F. Okay. And the next, there is also one more constraint, which is the foreign key. And let us discuss this foreign key constraint now. Okay. So what is a foreign key? When we actually were creating the original thing, when we actually created the employee table in above, what we had actually done, we had two tables, right? So the very first table that we had was employee data, in which there was an employee ID, his department, and let us say his title and all those things. Okay. Let us say we had one this table. And the second table was, let us say, employee salary. And this had employee ID, and this also had salary. Okay. So if we have these two things, does it make sense? Does it make sense that, hey, there is an employee, but an entry corresponding to him is not present in the employee salary table? Does that make even any sense? No, right? Because if there is an employee here whose department is, let us say, tech, and his title is, let us say, CTO, then there can be another ID 2 whose department is, let us say, program management, and whose title is, let us say, hey, let's say it's a general one, it's program management 1. Then there can be another person 3 who is also a program manager. Let us say his title is PM2 and all those things. And let us say there's 4 who is in tech and he's software engineer 1. Let us say these are the rows that we have. And corresponding to ID 1, I have a salary, let us say 200, 2000, let us say, and I have a salary 2, this is 3000. I have a salary 5, I have 6000, and I have a salary 3 who is, let us say, 4000, and I have a salary 4 who has, let us say, 2000. Does this make any sense? I'm like, there is a salary of an employee, but that employee does not exist. This does not make any sense, right? I mean, like, there should not be. I mean, like, there should not happen that, hey, in employee salary, there is an ID. There's an ID, but that ID is not present in employee, right? So we need to ensure that if an employee salary is present here, that employee ID should also be present here as well, right? So we can add a foreign key to the employee salary table, but what should that foreign key reference to? That foreign key should refer to the ID column of the employee table. Okay, so what can it do? It can say, I mean, like, how can we add this? I can say that, hey, when I create the employee salary table, I say create table employee salary. Okay, when I'm creating the table, I need to have an ID. Then I also, this is an integer. Okay, and I also need to have, let us say, the salary, which is also an integer. Okay, now I need to add a foreign key. What is the foreign key upon? Foreign key is upon this ID, right? Foreign key I add upon this ID. But what should this foreign key refer to? What should this foreign key refer to? This foreign key should refer to ID in employee table, right? So I say foreign key ID references, this references employee ID. Okay. So this is how I create a foreign key. If I forget to create foreign key, I can just, I mean, like we add primary key later, we can do alter table foreign key, alter table employee salary, alter table employee salary. And then what I do, I have to now add a foreign key, right? So I add a foreign key. I add a foreign key upon which column? I add a foreign key upon the ID column, and this references employee ID. Okay. So this is how I can add a foreign key later as well. Okay. By the way, I mean, like, anytime when we have to do a modification to the data, whenever we have to do any modification to the data, we actually have to use this alter command. This alter, as we know, is a data definition thing, and this can actually, I mean, like, alter the table, alter the definition of the data. This allows you to do that. Okay. Okay. Finally, I think there is one more confusing thing that I actually saw someone in the comments. What is the difference between drop, delete, and truncate? What is the difference between these three things? I mean, like, these three things in English wise mean the same thing, right? These three things mean the same, that, okay, you are deleting something probably. Okay. But is there any difference between these things? Why does SQL has these three things? Well, like, why? Okay. So the difference between these three things is that, hey, delete is used to delete a row from a table. Delete is just opposite of select. Okay. In select statement, you select some set of tables to view. But in delete command, you select a particular set of records to remove them from your SQL table. Okay. So I mean, like, what you can do is, suppose you have to delete all those students. I mean, like, suppose your university decides to remove all the students who had less than 40 marks. So what less than 40 scores. So your university can do delete from students. Okay. Then you can use everything here where what you use in select statement. So you can use everything here. So you can select where, let us say, score is less than equal to 40. This will do what? This will just remove every, I mean, like, every data from the student table, from the students table that had a score in which a student existed who had a score less than equal to 40. That is a delete command. Then there is also a truncate command. What this truncate command is used to do, this deletes all the rows. This deletes all the rows. But table is still there. But table and its definition, constraints, everything is there. Definitions, constraints are still there. And then the final thing is drop. Remove every existence of the table. Okay, remove complete existence of the table. So let us actually give you an intuition of this with a diagram. Okay, suppose we had a table like this. in which we have an ID, in which we have a score. Okay, let us say we have an ID 1 whose score is 50, ID 2 whose score is 60, ID 3 whose score is 20, ID 4 whose score is 10, ID 5 whose score is 70. Okay, let us run 3 commands here. Let us run, and this is ID and this is size. Okay, this is suppose the table, and let us say the first command that we run is the delete from students where score is less than equal to 40. What will this return to? This will change it to ID and score, and this has 150 because this is there, 260 and 570. Okay, other things will get deleted. You do truncate. If you do truncate, you are only remaining with ID, score. No data is remaining. Okay, nothing else is remaining. And if you do drop, nothing is remaining. I mean, like, there is complete empty thing. Nothing is remaining. Yes, Rahul, where clause can be applied in delete. That is what we have written here, right? Yeah. So let me actually give an example of how to write the truncate command. To completely remove the students table, you can do truncate table. I mean, like, to truncate all the data that is there in this. So you can do truncate table students, and to remove the students, I mean, like, to go into this thing that there is no existence of students table at all, you can do drop table students. Okay, so they completely remove the data, or the second thing, the drop table actually completely removes the whole existence that is there of that data. Okay, yeah, so that's all that I had from my side today. I hope you liked the session. It went for around 2.5 hours. So yeah, thank you for being a very patient listener. And okay, and by the way, guys, I mean, like, we have actually a very I mean, like, all these things we have actually written into a well-defined article as well on the interview bit platform. So that is present on this particular link that I've just pasted on the chat. So please, I mean, like, if you want to practice all these SQL statements, you can actually write those SQL statements there and see if the SQL code that you wrote was also good. Okay. Yeah, awesome. Have a good night. Please stay safe and stay healthy.